Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for CBSE Class 11 Applied Mathematics. So following the previous exercises, this session we are about to work out exercise number 6.5 from our standard book ML Aggarwal and Neeraj Raj Jain, and this exercise is going to be under the concept of sequence and series. So as I told, we have already completed the first 4 exercises 6.1, 0.2, 0.3 and 0.4. You can see those videos. They are very much important for you to understand this upcoming exercise, which is going to be this exercise 6.5. So we'll first of all go through some basics. Okay, what are all the concepts under which you will be getting questions from this particular exercise. We'll have to go through few basics and only then we'll be able to solve problems from this exercise. So let us just brush up few basics that we need to do here for this exercise. Okay, so if you see, this exercise is based on sum of the terms of a geometric progression. So you remember the previous exercise 6.4, we saw about the basics of geometric progression. So how will be a GP and how will be the terms and what is the nth term, everything we saw, right? And also we saw about what is the condition for the terms to be in a geometric progression, everything we saw there, and also we solved problems based on those concepts. And here this exercise we are going to see about sum of the terms of a geometric progression. Okay, all right. And particularly if you want to see, we are just going to see about the sum of n terms of a GP. This is what we are going to see here. Okay, so for that what I am going to do is I am going to take the first n terms of a geometric progression. Okay, all right. Yes, we'll begin from there. Okay, so if you see here, the first term is as usual going to be a, correct? So we'll start from a. Then what is the second term? Second term will be AR. Next third term will be AR square and so on. And we'll be going like this. And how it will be ending? It will be ending with AR power n minus 2. And what will be the last term, nth term? It will be AR power n minus 1. These are going to be the terms. Correct? Yes. So these are the terms for a geometric progression, and we are going to find the sum of these terms. This is going to be our task. Okay, all right. Yes, yeah, fine. So what I'm going to do is I'm going to take the notation Sn. Okay, I'm going to take the notation Sn to represent the sum of all these terms. Yes, shall we do that? Yes. Okay, so Sn will be equal to, it is nothing but we have to just add all these terms. That's it. Okay, so it will give you a plus AR plus AR square and so on up to AR power n minus 2 plus AR power n minus 1. These are what we will be getting. Correct? Yes. So if you add all these terms, this will give you the sum of the first n terms of a GP. That's it. And we all know very well about what is that A, what is that R, everything. A is the first term of the GP and R is the common ratio of the GP. Okay. And if you are not clear with these basics, please go through the previous exercise number 6.4. Okay. There you will be able to see all the required basics there. So once you are thorough with that, you will be able to understand these things. Okay, fine, all right. Yeah, coming back. So this sum is what we have to find it. Okay. So now what I'm going to do is, in order to find the sum, I'm just going to do one additional operation. Okay. So what I'm going to do is I'm going to take this as this equation as equation number 1. Fine. Okay, all right. Yes, let me mark it as equation number 1, and I'm going to multiply this equation number 1 by R. Fine. Okay, so what will happen if you do that? Shall we see that? Now what happens is this becomes R times Sn. Okay, R Sn. This will be equal to now each of these terms will be getting multiplied by R. Correct? Yes, that is what happens, right? So now what happens, this A will be multiplied by R. It becomes what? It becomes AR. Next, plus what about this AR into R? AR will be multiplied by R, correct? AR into R will be AR square. Okay. Now if you see, when you multiply by R, you are getting the very next corresponding term. That's what you are getting. Okay. And for that reason, I'm just correspondingly writing the terms. Okay, fine. Yes. And so on and so on. What happens next is, here also if you multiply, what happens? This will become what? This will become AR power n minus 1. So like the previous term, when it is getting multiplied, you will be getting a AR power n minus 2 plus here if this term is multiplied by R, what happens? AR power n minus 1, and last one, this nth term, when it is multiplied by r, what happens? You will finally get a r power n. This is what you will get. Is it or not? Fine, yes. So here you have n terms, and each of these n terms will be multiplied by r, and that will give you these new n terms. Okay, fine, yes. I hope you are able to understand this. Here we got n terms. I am multiplying each of them by r, and you can see here these will be the resulting n terms after getting multiplied by r. Okay, all right. Now we got another new equation. Let us mark this equation to be equation number 2. Fine, all right, yes. Okay, now we are going to find the sum. For this, what I am going to do is, I am going to do another small adjustment. What I am going to do is, I am going to just subtract these two equations. I am going to subtract these two equations. So what happens when you subtract? I mean, see here you have Sn, and here I have Rsn. So we are going to do minus. Okay, so what happens is, you will have Sn minus Rsn will be equal to, this will be equal to, now come to the right hand side. Left hand side we did the minus. Now what happens to the right hand side? Right hand side will become what? This will simply become, the common terms will be getting cancelled. Is it or not? See here, I can just cut these terms, AR and AR square. Similar way, this one and this one, this one and this one, everything will be getting cancelled. And finally what will happen? You will be left with only this A minus this AR power n. I hope you are able to understand this. Correct? Yes? Okay, yeah, fine. And what next I can do is, I will now find the value of Sn. That is what we needed here, right? So we need to find the value of Sn only here, right? So for that, what I am going to do is, I am going to take this Sn as a common factor outside. Okay, so I will take Sn outside. So what you will have inside? Inside you will have 1 minus r. Is it or not? Because from Sn you remove Sn, factor out Sn, you will have 1 here, and from Rsn you just factor out Sn, you will have r here. So between you have a minus sign, that will be staying as it is. So you will have 1 minus r times of Sn will be equal to, now come to the right hand side. Right hand side you can take a as a common factor. Is it or not? So when you take a as a common factor, what you will have inside? Here inside we will have 1 minus r power n. This is what you will have. Correct? Yes. And now we can easily get the value of what is Sn. So Sn will be equal to what? You will have a into 1 minus r power n whole divided by, I can bring this 1 minus r here so that it comes as divided by 1 minus r. So this is going to be the expression for what? This is what stands for Sn. I mean the sum of n terms of an GP, geometric progression. Okay, all right. I hope you're able to understand this. Okay. And if you see here, closely watch, you can perform the same subtraction operation in a different way also, in another way also, right? Yes, it is possible. How? Now at the beginning part, what we did here, when we tried to do the subtraction here, we tried like first equation minus second equation. That is how we tried, and that result is what gave us this. Fine, yes. And now this time let me do it in the reverse way. That is, we'll try to do equation number 2 minus equation number 1. Yes, we can even do that, right? So when you try to do that, like equation number 2 minus equation number 1, now what happens is, you will now have Rsn minus Sn will be equal to, this time it will be equal to, now you are doing second equation minus the first equation. So now what happens is, this is the only term left here. Okay, right? Yes, AR power n minus, here the left out term is A. So this will come AR power n minus A. Anyhow, in the similar way, the other common terms will be getting cancelled and you will be left with only these two terms. But since this time we are doing equation number 2 minus equation number 1, you will have this one coming here, AR power n, then minus this A will come here. Okay, this is what will happen. And as usual, here I can take Sn as a common factor. I will have R minus 1 here, and here I will take A as a common factor. I will have R power n minus 1. And now also I can find the value of Sn. So Sn will be equal to what? A into R power n minus 1 by R minus 1. So this is what you will be getting for the value of Sn. I hope you are able to understand this. Correct? Yes. So that means we are getting two different expressions for Sn, and of course to say they are not very different expressions, they are almost the same expressions. Okay, what here we have is A into 1 minus R power n by 1 minus R, but here we have is A into R power n minus 1 by R minus 1. just the values here are swapped. What we see inside the bracket in the numerator and what we see in the denominator, the values are getting swapped in both numerator and denominator, keeping the value, the whole value, I mean the entire value to be same. This is what is happening, okay. And in general, what we do here is, when you see these two results, two formulas, in general what we do here is, we will be using this first formula, okay, I mean this formula, SN formula, to find the value of the sum of n terms when here R, I mean the magnitude of R is less than 1. Is it okay? Yes. That is, when your magnitude of R is less than 1, we will be using this. What do you mean by that magnitude? Magnitude means the value that should be less than 1. No matter whether it is positive or negative, the value should be, I mean the magnitude value, okay, we'll call this to be modulus, okay, if that is less than 1, okay. So we'll be using this formula, okay, alright. So that means magnitude will be what? You can use these numbers where you can use this. When R is taking values like 1 by 2, 1 by 3, 3 by 4, 2 by 5, all these values, you can use this. And the same thing applies for the negative corresponding values also, like minus 1 by 2, minus 1 by 3, minus 3 by 4, minus 2 by 5. For those values, you can use this. And coming here, this can be used when you can use it for the reverse way. That is, when your magnitude of R is greater than 1, you can use this formula. Okay, that when R is going to take values like 2, 3, 4, or 1.5, anything greater than 1, okay, 1.5 or 2.5, 1.75, 1.8, whatever it is greater than 1, you can use this. And the same way, even if you have the magnitude to be greater than 1, that is minus 1.5, minus 2, minus 3, whatever, you can use this. Okay, fine, yes. So these are going to be the two results, and also we just discussed when we can use which formula, that's it, okay. And you can see one thing, R is less than 1 here, magnitude of R, modulus of R is less than 1, we can use this. Magnitude of R, I mean modulus of R is greater than 1, we can use this. What if R is equal to 1? What happens? Just think of what happens, because these two cases we have, but we don't have the case for R is equal to 1. What we can do there? When R is equal to 1, you can just imagine what happens to a geometric progression. Yes, okay. When R is equal to 1, you will not be able to use both these formulas. Correct? Yes, you will not be able to use the formulas. Why? Because this formula will go invalid when R is equal to 1. So in that case, what we will do is, you can just see when R is equal to 1, what happens to the terms here? Okay, just see Sn will become what? Sn will be equal to, just you can carefully see here. What happens to the terms here? Wherever R comes, you can put it as 1. That's it. Okay. So if you do like that, what happens is you will have A plus A plus A up to n times. So you will have n times of A coming here. That's it. Okay. This will be n times, and that means this will be simply equal to an. That's it. Okay. So this is what is going to be Sn's formula when R is equal to 1. Okay. Of course, this is going to be little rare, but still, for the case which is left over here, we are just taking this as an extra explanation. That's it. Okay. And anyways, R is equal to 0 is not allowed here. Correct? Because for a GP, we can't take R is equal to 0. That is not possible. And for the rest of these values, this is how the sum of n terms exist. Okay. All right. Yeah. And here we have got two special cases that also we will have to discuss. Okay. One is sum of the n terms when the last term is given. So when you are given the last term of the geometric progression, how we can find the sum of the n terms, that we have to see. Okay. So how can you find the sum when the last term is given, that we will see now. So when last term, what do you mean by the last term? Last term is nothing but the nth term, correct? So that means AR power n minus 1. This is going to be the last term. And now we can use the formula. Okay, in general, we will be using this formula. When magnitude of R is greater than 1, we have a formula, right? This is what we will use. So Sn will be equal to, Sn is equal to. So when you try to use this formula, now what will happen? We will just see that. Okay. So what is this formula saying? This formula says A into R power n minus 1 by R minus 1, correct? Now I will multiply this A inside. So I will have AR power n minus A divided by R minus 1. This is what you will have. Correct? Okay. Yes. Fine. Now see here we have got AR power n. Now I can adjust this. How I can adjust this is I can adjust this as AR power n minus 1 into R minus A by R minus 1. We can rewrite it like this, right? This is possible, right? Why? Because this a r power n, this r power n I am rewriting as r power n minus 1 into r. So that when you multiply, you will again get back the same r power n itself. Okay. Why we are doing this adjustment is, now you can see here in the place of this place, I mean this expression, we can substitute this value L here, because L stands for the last term, right? So we'll have LR minus A by R minus 1. So this is what is Sn's expression. Okay, fine, yes. So this expression is what you will have, and of course when you do the same thing here if you try to do the same thing, I mean substituting L is equal to AR power n minus 1, if you try to do it here, what happens? You will again get the reverse order. Okay, so that also I can just give it here. So Sn is equal to, you will be just getting A minus LR by 1 minus R. This is what you will be getting. So here again you have got two formulas for Sn. Okay, yes. So you can either use this or use this. That's it. Okay, and this you can do to find the sum of n terms. When you can do this, when you are given the last term of the GP, you can use this formula, okay, to solve the problem. And last one, coming here to the sum up to infinity. Okay, when you are asked to find what is the sum of the terms up to infinity, okay, there what formula we need to use, that is what we have to discuss. And for that you have to just go through one more important point. Okay, there's one important condition here. When you will have the sum up to infinity is when your r, I mean the magnitude of r is less than 1. For such problems only you will be having sum up to infinity. I'll just explain the reason why it is. Okay, fine, yes. Okay, now imagine when you have a geometric progression whose r value is less than 1. Now how will be it? How will be the terms? Basically the terms will be, it will be decreasing, is it or not? Correct? Yes, it will be shrinking with the size, is it or not? Suppose the first term is some value, and here AR will become what? Because your modulus of R is less than 1. Okay, you can even take some example for that. Let us consider R as 1 by 2. What if R becomes 1 by 2? You just substitute it here. So my first term will be some value, my second term will be half of that, my third term will be even half of the second term, and fourth term will be half of my third term. It will be going like this. So that means our size of the terms will be diminished, and at one point what happens? The terms will be converging to 0. It will become 0 at one point. Okay, yes. At this situation only we will be able to find the sum up to infinity. We cannot find the sum up to infinity when your modulus of R is greater than 1. That is also you can follow it logically. Why? Because if you have the first term, imagine what happens when R is greater than 1. Greater than 1 in the sense it can be 2 or it can be 3 or whatever it is. Okay, just for instance I will take 2. So now what happens if R is 2? We have the first term, and second term will be double of that, third term will be double of the second term, and fourth term will be double of the third term. So our numbers, our term size will be increasing and increasing. So you will never have an end. I mean at the end you will happen to get a very big number only. In that situation we will not be able to find the sum up to infinity. That is not possible. Fine. Okay, yes. So under this situation is what we will be using sum up to infinity when modulus of R is less than 1. There only we happen to use this. Okay, so we will represent this sum up to infinity as S infinity. This is the general notation. Okay, yes, because this is the infinity sign, right? That's why. Okay, now what will happen? We have to use Sn formula. Now which Sn formula we need to use here? We have to use this first case. Why? Because here only we have mod of R is less than 1. So let us use this formula. Okay, now A into 1 minus R power n by 1 minus R. This is what you have, right? Now imagine about this structure. Okay, I mean the structure of this R power n alone, you just concentrate on it. Now our R value is less than 1. Okay, and I will take the same example itself. Let me take the same example itself. That is, we will have what? 1 by 2. Let us have R as 1 by 2. Okay, and here what about our n? Since we are finding sum up to infinity, our n value also tends to infinity. Is it or not? Is it or not? So in that case you can imagine and tell what will be our minus 1 by 2 power 1. This will be what? This will be simply 1 by 2 only. But what happens if you still increase the power? 1 by 2 power 2, 1 by 2 power 3, 1 by 2 power 4. What happens? If you see 1 by 2 power 2, it will be even more lesser. It becomes 1 by 4. Like 1 by 2 power 5, if you come to calculate, it will be 1 by 32. It will be even very, very lesser. Correct? Yes. So at some stage what will happen? This 1 by 2 power infinity, you can even take it as infinity. 1 by 2 power infinity will be very, very close to 0. Is it or not? Yes. So now when you try to find sum up to infinity, this r power n's value will be almost 0 or it will tend to 0. Correct? Yes. When n tends to infinity, that is the meaning of s infinity, right? So in that case, this r power n also will tend to 0. So that means this term will exactly become 0. Okay, fine. Yes, we will take this value to be 0. So in that case, now what will happen for the s infinity's value? So this becomes a into 1 minus 0 by 1 minus r. So that means this is simply s infinity is equal to a by 1 minus r. That's it. Okay, fine. So this is the formula for you to find s infinity. I hope the structure is very clear to you. Okay, so we started from here, we found Sn for these two different cases, and also we saw when to use this and when to use this. And when r is equal to 1, what will be the formula? This is the formula. And the other two cases, when the last term is given, how to find Sn and how to find sum up to infinity. When it is specified in the question sum up to infinity, we will have to use this formula. Apart from that, we will have to use these formulas only. Okay, all right. So this is going to be the structure. I hope it is clear to you. Again, you have a view once again. You will be able to understand all the things. And yes, please do note all these things, because all these things we will be using in the problems when you are going to solve these questions. Okay, yes. So for that thing, it is I'm just insisting you to note all these things. Okay, it is really important for you to know all these things. So kindly note all these things. And now we will just get into the problems. Starting with the first question. Here we have find the sum of. We have got few subdivisions here. The first two subdivisions among them is what you can see here. So coming to the first subdivision, find the sum of the first 20 terms of the sequence. Here we are given a sequence 0.15, 0.015, 0.0015 and so on. So for this given sequence, we have to find the sum of the first 20 terms. This is the question. And if you closely observe, the given sequence is going to be what kind of sequence? This is a geometric progression. Okay, all right. So for this GP, we need to find the sum of the first 20 terms. This is the question. Okay, all right. Yes. So first of all, we'll just try to modify the given terms. Okay, all right. Yeah, we'll start from there. Now see the first terms. First term we have here as 0.15. So the 0.15, I can write it as a fraction as 15 divided by 100. Yes, is it or not? We can write like this, right? So we can write like this, 15 by 100. Why? Because you can see here, I have 0.15. So that means the whole number which is present there is 15. And there are two places after the decimal point. So for that reason, it is going to be 15 by 100. I can write like this. Okay. Same way, this 0.015. This can be written as what? I can write this as 15 by. Now here if you see there are three decimal places. So I can divide this by 1000. Okay. I hope I can understand these basics, right? Okay. So we have to add this. Okay. 15 by 100 plus 15 by 1000 plus 15 by. This one is going to be again 15 by. Here we have four places. So that means we have to divide by 10,000. Alright, so this way this sequence is going. So when you look at this itself, you can observe that this is going to be a GP. Okay, yes. For this GP, what we have to find? We have to find the sum of the first 20 terms. So that is S20 we have to find. We know the formula for Sn. So Sn formula we have here. And we need to use that formula to get the answer. But before even using that formula, we need to find the values of A and R. Is it or not? So those two values are important, right? We need to find the values of A and R. Anyways, we have the value of N in the question itself. N is going to be what? That we will note down here. N is equal to 20. Is it or not? Why? Because there are 20 terms. So the number of terms is what is N, correct? So N is equal to 20 and A and R only we have to find now. Okay. So what about A value? A is going to be how much? You can see here. A is what? A is the first term, right? So first term is 15 by 100. So 15 by 100 is what is A. And if you want, you can even simplify it, right? So 15 by 100 can be simplified as what? It can be simplified as 5 3s are and 5 20s are. So it can be written as 3 by 20. So A is equal to 3 by 20. This one we have. And next is R value also we need to find, correct? R also we need. So R, how can you find R? R, I will take this space, okay? So R is equal to, so usually how do we find R for a GP? It's very simple, right? Last exercise also we have seen that, right? We have to take the second term, divide by first term. That's it. Okay, you can take any two consecutive terms, next terms. So we can divide the latest term with the previous one. Okay, so that is how we are we are finding the value of r. So here I can see this first and second terms, right? I can divide the second term by first term, that I can do. So if you divide, what happens? You will have 15 by 100, sorry, 15 by 1000, that's my second term, right? I'm sorry, 15 by 1000. This one divided by what? This one divided by 15 by 100. This is what I have to do. Now I am going to do a small thing. I will just into 100 by 15. I will do like this. We can do this, right? Because 15 by 1000 into 100 by 15. Because I am dividing this by this. Since I am going to divide by 15 by 100, it is equivalent of multiplying with its reciprocal 100 by 15. That's it, okay? So we can cut these two 15 and 15, and now I can cut these two zeros. So finally we have what? R is equal to 1 by 10. So this is also done. So that means we have the value of n is equal to 20, and a is equal to 3 by 20. This is also there. And finally r is equal to 1 by 10, that is also there. So everything is available now. Now we can find the value of the sum of first 20 terms, that is S20. We can find the value. Fine, okay? So S20 means again we have to use the formula, Sn formula. But which formula we have to use here? We have got two formulas for Sn, right? Which formula we have to use? That is decided by the value of r only. See the value of r is going to be 1 by 10, is it or not? So in that case, r is 1 by 10 in the sense we have to find the sum using this first formula. Why? Because when the magnitude of r is less than 1, this first formula is what we are supposed to use, is it or not? So in that case, we will use this formula to find the answer, okay? So Sn is equal to a into 1 minus r power n by 1 minus r. This is what we have to use. So we'll have the value substituted here. So first of all, a comes, so a is 3 by 20 into I'll open a bracket, 1 minus r power n, 1 minus, what about r? R is going to be what? 1 by 10. So 1 by 10 whole power n. So n is what here? N is going to be 20 here. So substituted. So appropriately we have to substitute. That's it. Okay. Divided by 1 minus r. So that is 1 minus 1 by 10. That's it. I hope you can understand this. Okay. Simple substitution only. So be clear with the formula which one we have to use. Then properly substitute the values. Okay. So this is equal to, now all we need to do is we have to simplify this given fraction. Okay. This calculation. Okay. So first of all, what I can do is I will just write this 3 by 20 into 1 minus. Now see here, what do we have here? Here we have 1 by 10 the whole power 20. Now this power 20 is common for both this numerator as well as denominator, right? So that means what I can do is 1 power 20 is going to be 1 only, divided by 10 power 20 can be written as 10 power 20 itself. Correct? Yes. Divided by, now come to the denominator. Here we have 1 minus 1 by 10. So this can be simplified as what? So I can just multiply this 10 into 1. 10 ones are 10. 10 minus 1 will be 9. So 9 by 10, this is what I will have. So now again we can simplify. So I can simplify this 3 by 20 divided by 9 by 10. Okay, let us be careful. Okay, so you can even you can bring it like this by as a reciprocal, like that you can simplify, or otherwise you can even simplify it here itself. Okay, but the only thing is you should be a little careful. That's it. Okay, so look how I am going to simplify this. So first I am going to take these two numerators, this 3 and this 9. I am going to take these two numerators, I mean the numerator of the numerator and numerator of the denominator. This is what I am doing. Okay, so 3 and 9, this is 1 times and this is 3 times. I am cancelling this. And what next I can do is I am going to take both the denominators, I mean the denominator of the numerator and denominator of the denominator. Okay, I'm going to take these values. So I will have 20 and 10. This is exactly 2 times. So finally we have what? 1 by 2 in the numerator, and you have simply 3 in the denominator. Okay, I think we can multiply this 3 with this 2, right? Because this denominator and this one, they get multiplied. So finally what do we have? 1 by 2 3s are 6. So you will have finally 1 by 6 into 1 minus 1 by 10 power 20, and this is going to be the grand answer for our question number, I mean subdivision number 1. The sum of the first 20 numbers, 20 terms of this GP is going to be the answer. This is going to be the answer. And see here you have 10 power 20. Okay, its value is going to be very large. So since its value is very large, we are not going to take the simplification process for this expression. Okay, we are just leaving it as it is. If the power is going to be countably less, means that means you can simplify, but here it is going to be very huge. In that case you can leave the steps as it is. So 1 by 6 into 1 minus 1 by 10 power 20 is going to be the answer for our first subdivision. I hope it is clear to you. Okay, yes, all right. Yeah, simple thing only. We are just taking the relevant formula and we are just taking the values of a, r and n and then substituting it and then getting the answer. Okay, all right, yes. Yeah, coming here to the second question. Here we have what? Second subdivision we have. Find the sum of the first 5 terms and n terms of the series. So we need to find the sum of 5 terms and then n terms. Okay, both we have to find. Okay, so let's do a thing now. First of all, we'll try to find the sum of n terms here. That we will find it first. Okay, so we'll try to find the sum of n terms here, sum of n terms. Okay, but even before that, what you have to do, we have to be sure about which two values. We should be able to find the values of a and also r. A is simple, right? For our sequence series, what is our series here? 1 plus 2 by 3 plus 4 by 9 and so on. Okay, this is going to be our series, and the first term is 1. That is seen very easily, it is visible easily. So a is 1. And what about r? R is going to be what? R is going to be, as usual, second term minus divided by first term. Okay, I'm sorry, second term divided by first term. You've got the first two terms of the GP, right? So what you can do? Second term divided by first term, you can do that. So if you do that, you will have 2 by 3 by 1. So that means r is equal to 2 by 3 only. That's it. Okay, finished. You can even do third term by second term. That also you can do. Okay, yes, anything you can do. Third term by second term, or fourth term. If you have fourth term by third term, anything you want, you can do it. Okay, you can pick any two consecutive terms. You have to divide the latest term by the previous one. That's what we are doing here. So r is 2 by 3. So a is 1. Okay, fine. Now we are going to find the sum of n terms, that is Sn you have to find. Okay, so what about Sn expression? Sn is going to be what? Sn is going to be simply, it is going to be like a into which formula we have to use here basically. So here we are going to find Sn. Which formula we have to use? We have to use the first one or second one. Again, you have to see the value of r. R is going to be 2 by 3 and this is less than 1. Is it or not? So again, you have to use the first formula only. Okay, yes. So Sn is equal to, yeah, let's take. So a into, that is 1 into 1 minus r power n, that is 2 by 3 power n. 2 by 3 power n. Okay, I'll use square brackets. I'm sorry. Yeah, square brackets I will use. Divided by 1 minus r, divided by 1 minus 2 by 3. This is what you will have. Is it or not? Yes. Yeah, fine. So this is equal to, now what next I can do is I will just divide this by, this is anyways 1 into this one. So this will become 1 only. Okay, yes. Yeah. So you will have only this expression there. 1 minus 2 by 3, the whole power n. Okay, this is what you will have. Now coming to the denominator, what do you have in denominator? 1 minus 2 by 3. You have 1 minus 2 by 3. What is 1 minus 2 by 3? You will have 3. 1s are 3. 3 minus 2 is 1. So you will finally have 1 by 3 in the denominator portion. So this is what you have. So Sn is equal to, you can again bring this 3 to the numerator portion. So it will become 3 into 1 minus 2 by 3, the whole power n. So this is what you will have. Is it or not? So this is going to be the expression for Sn. Okay, yes, all right. And what else we are asked to find? We are even asked to find the value of the sum of the first 5 terms. That is simple. In this expression, you can put n is equal to 5. Okay, so this will give the sum of first 5 terms. So we have to find the value of S5. So shall we find it? S5 is equal to 3 into 1 minus, just replace n as 5. That's it. Okay, 2 by 3 the whole power 5. This is what you can do. So what next I can do here is, this is equal to 3 into, so now 1 minus, what about 2 by 3 the whole power 5? This can be written as 2 power 5 by 3 power 5. Okay, yes. So what is 2 power 5? 2 power 5 will be 32 divided by 3 power 5 will be what? So already 3 power 3 square is 9. And next is 3 square into 3 square. 9 9s are 81. 81 into 1 more 3 if you do, you will have 3 power 5. Correct? Yes. Because 3 square is 9. Another 3 square is 9. 1 more 3 you can join. Okay. So 81 into 3 you will have 243. So 243. This is what you will have. So now we have to simplify this expression. So if you come to simplify, you will have what? So you will have 3 into. So this one will become 243 minus 32. What is 243 minus 32? We can do it mentally. So 243 minus 32 will be 3 minus 2 will be 1. 4 minus 3 will be 1. And this is 2. So 211 divided by 243. And finally, you can even cut this 3 and 243. This is exactly 81 times. Is it or not? Yes. So finally, S5 is equal to what? 211 by 81. So sum of the first 5 terms, the answer is going to be S5. This is the answer. Okay. So actually this is going to be the answer for the first question. 5 terms, the answer is 211 by 81, and sum of n terms is going to be, this is the expression. Okay, these are going to be the answers for our second subdivision. I hope this is clear to you. So use the appropriate formula based on what value r is taking. Based on that, you will have to take the correct formula and then you have to do the proper substitution to get the answer. Okay, yes, I hope everything is clear to you. Yes, have a look. Yeah, these are going to be the answers for our first 2 subdivisions. Yeah, we'll move to the next subdivision. Moving to subdivision number 3, here we have, find the sum of the first n terms of the sequence, root 7, root 21, 3 root 7 and so on. This is how this sequence is going. So as usual, let us just try to find the value of a and r. A is going to be what? The first term, that is going to be root 7. And what about r value? R will be the second term root 21 divided by the first term root 7. So this is how we can divide to find the value of r. And here I can do some kind of simplification. Okay, so let us rewrite this root 21 as this 21. We can factorize it, right? So this can be factorized as 3 7s are 21. Is it or not? So in that case, I'm going to rewrite this 21 as root 21 as root 3 into root 7. Fine. Okay, all right. Divided by root 7. We can write like that, right? Yes. Root 3 into root 7 will anyways they get multiplied to give you root 21 only. That's how. Okay. Yeah, fine. Now I can cut this root 7 and root 7. So we will be left with r is equal to simply root 3. This is what we'll be left with. Okay, fine. Yes. So we are ready with a and also r. Now we can go for the finding. Go for the, we have to just find the value of the sum of the first n terms, right? We can go for that process. So that means we have to find the value of Sn here. Okay. And next, what next is we have to see the ratio. Okay, r value we have to see. R is going to be root 3, right? So what about this root 3? Root 3 is greater than 1, is it or not? So a is root 7, that is okay, and r is root 3, and this root 3 is greater than 1. So that means here we are supposed to use the Sn formula, what we see here. Okay, yes, we can use this formula. Anyways, remember one thing, both the formulas are equivalent only. Okay, so the way we are choosing it, which one will be comfortable, okay, which formula we can use so that will be comfortable to solve the problem. That's it. Okay, for which we are just looking at the value of r. That's it. Okay, but anyways, both of them are equivalent formulas only. They are not going to be two different formulas and all. They are going to be the same formulas only. Okay, yes. So just for a comfortability, convenience, we are using for the corresponding formulas based on the values you see for r. That's it. Okay, yeah, yes, Sn is equal to, we'll take the second formula. So that says a into, so a is root 7 multiplied by r power n minus 1. Okay, r power n minus 1, that means root 3 power n minus 1 divided by what about the denominator? R minus 1, that is root 3 minus 1. So this is what we have. So see here, your denominator we have a third term, is it or not? So in order to rationalize this, what we can do a conjugation process. I'm going to multiply this by root 3 plus 1 divided by root 3 plus 1. We can do this, right? Yes, so that we can rationalize the denominator term. That's right. Okay, yeah, fine. So you will have Sn is equal to, so this will be multiplied. So root 7 into root 3 plus 1 into root 3 power n minus 1 whole divided by, now come to the denominator portion. What do you have here? Denominator we have root 3 minus 1 into root 3 plus 1. Actually, this is in what form? This is in the form of a plus b into a minus b, is it or not? So you have a minus b into a plus b. So this is equivalent to what? This is going to be equal to a square minus b square, is it or not? So that means we will have root 3 square minus 1 square. So this is what we have here. So now I can do it like what? I can do it like this will be root 7 into root 3 plus 1 into root 3 power n minus 1 divided by, now what about this denominator? We have root 3 square minus 1 square, that means this is 3 and this is 1. So 3 minus 1 will give you only 2. So your final answer will be, this expression is going to be the final answer for our subdivision number 3. I hope you are able to follow this. Not very much complicated calculations. The only thing is we should be clear with the roots. Okay, so one conjugation process we are doing here in order to rationalize our denominator. That is what we are doing here, so that the problem will be cleared. Okay, yes, this is going to be the answer for our question number, subdivision number 3. And coming to the fourth subdivision, here we have find the sum of n terms of the sequence. See the sequence here, we have x cube, x power 5, x power 7 and so on, and they themselves gave the thing like x is not equal to plus or minus 1. Okay, fine, yes, yeah, fine. So as usual, we'll start from the first term. A is equal to x cube, and what about r? R is equal to what? We can find it as t2 divided by t1, that is we will take x power 5 divided by x power 3. So you divide this, you will be getting the value of r. So you will get what? X power 5 by x power 3 will be nothing but x power 5 minus 3, which is going to be 2. That's it. Okay, so a is x cube and r is x square. I hope you are able to follow this. So when you have x power 5 by x power 3, what we have to do? This is a well-known axiom, right, in exponents. when we have same powers divided, I mean same bases with different powers divided, what we can do, the powers, we can subtract the powers, okay. The numerator's power minus denominator's power, we can subtract, we can do 5 minus 3, that is what is this 2, okay. So we are ready with A and also R. But here the thing is, we are not sure about the value of R, okay. So that means we will go for default the second formula itself, okay. Yes, fine. So if we go for that, we will be getting what? We have to find the sum of n terms only, right? So Sn is equal to, we will have what? We will be having A into, that is x cube into, what about, I'm sorry, I will just open a square braces, okay. So that will be easy for our calculation, okay. Okay, open. So x cube into R power n, that is x square power n minus 1 divided by R minus 1, that is x square minus 1. This is what we have here. Is it or not? Yes. I hope it is clear to you, right? Yes. Fine. So when simplifying this, we will be having x power 3 into, this will be x square power n. So this becomes x power 2n minus 1 whole divided by x square minus 1. Okay. Yes. So this is going to be the simplified step for our question number, subdivision number 4. So this is how we can just get the answer for our sum of n terms of this given sequence, okay. Yes, and since we are not clear about the value of x, we will not be able to further simplify, okay. Yes, if we have the value of x now, we can even substitute and then do, but leaving this one as it is, it's going to be better, okay. Fine, all right. So these are the answers for your third and fourth subdivisions. Next is subdivision number 5. We have to find the sum of infinite terms of the sequence, okay. And of course, sixth subdivision is also based on the finding the sum of infinite terms only. Yes, at this point, let us just remember the formula what we need to use for finding the sum up to infinite terms, okay. So we'll remind that here itself. So what is S infinity? S infinity is nothing but what? A by 1 minus R, okay. We have seen this in the introduction part itself, right? You can even revise it, okay. We have even see how this is derived, okay. That also we have seen there. So you can have a revision there. S infinity is equal to A by 1 minus R. This is going to be the formula. Coming back here, for this sequence, we have to find S infinity. This is the question. Okay. All right. Yes. Fine. As usual, we have to find the values of A and R. Is it or not? So A will be what? A is equal to simply 7. It's going to be the first term. So 7. And what about R? R will be nothing but what? R will be term 2 divided by term 1. All right. Yes. So what is term 2 here? Term 2 is minus 1 divided by term 1 is 7. So minus 1 by 7. That's it. Okay. It's very open here. So we found the values of A as well as R here. Very simple. Now directly we can go find the value of S infinity. So S infinity means sum up to infinite terms. Okay. So this is equal to A. Okay. So A, we have 7 divided by denominator, we have 1 minus R. So 1 minus 1 by 7. I hope this is clear to you, right? Yes. Fine. This is 1 minus 1 by 7. Since R itself is negative, we are doing this, okay. So 7 divided by, now what you have here, 1 minus 1 by 7 will become 1 plus 1 by 7. So that in turn becomes 7 by, what about 1 plus 1 by 7? This is 8 by 7, is it or not? Why? Because we can just do 7 into 1, 7, 7 plus 1 is 8, 8 by 7. So we have got 7 by 8 by 7. So that means this, when you simplify, you will be getting the answer as what? This 7 goes here to the numerator portion. So this becomes 7 7s are 49 divided by 8. So S infinity is equal to 49 by 8 is going to be the answer for our subdivision number 5. That's it. Okay. Coming to the sixth question, we are going to work this question also in the same way how we worked there. So like here you have the value of A is equal to what? A is the first term, root 2, and again we have to find the value of R. Okay. So R is equal to what do you have? Second term divided by first term. Okay. So second term is minus 1 by root 2 divided by the first term is what? Root 2. Okay. So this is going to be a series, right? We have to find the infinite terms, sum up to infinite terms. So now I can simplify this as minus 1 by, this root 2 will come here to the denominator portion. So this becomes root 2 into root 2. So you will have R is equal to minus 1 by, what about root 2 into root 2? It will simply become 2. Okay. So here A is root 2 and here R is minus 1 by 2. Okay, fine. All right. Now we can go find the value of S infinity. S infinity, again we are supposed to use the same formula, A by 1 minus R. So A is going to be root 2 divided by 1 minus R. So what is 1 minus R? 1 minus 1 by 2. Okay, yes, all right. Fine. Okay. So root 2 divided by 1 plus 1 by 2. So this becomes minus of minus plus 1 by 2. So now it will become root 2 divided by, what is 1 plus 1 by 2? This will be 2 ones are 2, 2 plus 1 is 3, so 3 by 2, this becomes 3 by 2, and now I can bring this 2 to the numerator portion so that it becomes 2 into root 2 divided by 3, okay, why? Because this is like root 2 divided by, okay, this is an entire divided by, okay, entire divided by 3 by 2, this is what we have here, 3 by 2, we have the denominator, and denominator will become the numerator, it will go to the numerator, okay, so 2 into root 2 it will become, so 2 root 2 divided by, only this 3 will stay in the denominator portion, so our final answer becomes 2 root 2 divided by 3, and that's going to be the answer for our subdivision number 6. So I hope these two questions are also clear to you, and now we'll move on to the next question. Next we have question number 2. So here the question is, find the sum of the series 81 minus 27 plus 9 minus and so on up to minus 1 by 27. So that means here if you see this given series, this geometric progression, we have got what? We have the last term, the ending term is given to us, is it or not? So when you have the ending term is given, for that also we have seen what formula to be used to find the sum of the terms. Yes, so you can view it here. So these formulas are what we have to use. Yes, okay, all right. And again for this also we should be sure about what? The values of A and R. So first of all, let us try to find the values of A and R. A is very easily visible. A is the first term, so A is going to be 81. And what about R? R is equal to what? We can as usual find it as second term divided by first term. So you have R is equal to minus 27 by 81. Yes, okay, yeah, fine. So that means R is equal to, you can even simplify this, right? So 27 and 81, it is exactly how many times? 3 times. So you will have R is equal to minus 1 by 3. Okay, fine, yes. So that means we are ready with A value and R value. And also in this question itself, we have the value of the last term. Last term is what? The ending term is what is the last term? Okay, L is equal to minus 1 by 27. This is also given. Okay, so these three values are enough for us to find the answer, right? Yes. And which formula we can use here appropriately? So here, since the value of R is less than 1, okay, I mean the magnitude of R is less than 1, it is better to use this formula. Okay, all right, yes, we can use this formula. I mean this R is less than magnitude of R is less than 1, we can use the first formula. That's what I come to say, I'm sorry. So the first formula, we have A minus LR divided by 1 minus R. We can use that formula to solve and get the sum of this given series. Okay, so Sn is equal to A minus LR. Let me write that formula once. So A minus LR by 1 minus R. Okay, so this is equal to, we know the values of A, L as well as R. All of them are available here, right? So we can substitute it. So A is going to be 81 minus LR. Okay, so LR will come. So LR means minus 1 by 27 into minus 1 by 3. So this is what you will have here. Yes, fine. So this is what you will have here, right? So 81 minus 1 by 27 into minus 1 by 3. I hope you can understand this, because this is the value of L and this is the value of R, divided by 1 minus R. So 1 minus R is going to be minus 1 by 3. So we have to simplify this expression to get the answer. So this will be equal to, so now what I can do here is 81, this is minus, so anyways I will have minus into minus as plus only. Okay, fine, yes. So you will finally have 1 by 1 ones are 1 divided by 27 into 3 is going to be again 81 only. Oh, okay, yes. Is this clear? Don't again put a plus. Okay, you have a minus already, and these two minus into minus will become a plus. Okay, fine, yes. And outside you have a minus, that minus will be staying as minus itself. So you will have numerator as 81 minus 1 by 81. This is what you will have in the numerator. And now divided by denominator, what will happen? You have 1 minus of minus 1 by 3. So this will become minus of minus. So this will become 1 plus 1 by 3. Okay, fine, yes. Yeah, okay, yes. Next, what you have here is, coming back to the numerator. Numerator, you have what? 81 minus 1 by 81. So how to simplify this? You will have to do it like 81 into 81 minus 1. Yes, okay. 81 into 81 minus 1. So it will be like 81 into 81. What is 81 into 81? It will be 81 square, right? 81 square will be 6561 minus 1 divided by 81. Okay, yes. Yeah, fine. If you want, you can even work it out and then see. Okay, so 81 into 81, I will just work it out and show. So 81 into 81, right? 1 ones are 1, 1 8s are 8, and 1 8s are 8 is 16. So balance 1. So 8 8s are is going to be 64 plus 1 is 65. So 6561, that's what I've written here. So 65 minus 1 divided by 81 divided by, once again divided by, come to the denominator portion. Here you have what? 1 plus 1 by 3. So what is 1 plus 1 by 3? This is not going to be a very big calculation. This is simply going to be 3 ones are 3, 3 plus 1 is 4. So 4 by 3. This is what you will have. Okay, alright? Yeah, fine. Now coming back. Here, this numerator, once again, I can simplify it as what? 6561 minus 1. So, this will become 6560 divided by 81. Okay, fine. I am just taking the numerator part around. 6561 minus 1 is 6560 divided by 81. So, this I completed, the numerator portion. And see here, denominator I have 4 by 3. Now, I am going to write it as into 3 by 4. You can do this, right? Yes, we can do this, right? Because this is divided by 4 by 3. I am just taking that to the numerator part. I am just taking it to be into multiplied by 3 by 4. That's it. Okay, fine. Yeah, okay. Now what happens is like this 3 and this 81 will become, just we can cut it. It will become exactly 27 times, right? Okay. So 3 27s are 81. So I can cut this 27 times. And also I can cut this 4 and this 6560. So this will be how many times? 4 16s are 64 and balance will be 1. So 4 40s are 160. So you have 1640. So finally you have 1640 in your numerator divided by 27. So this is going to be the simplified answer for our question number 2. I hope it is not much complicated for you to understand. So see here, we just take the values of A, R and also L is available in the question itself. So use this formula. I mean sum of n terms when the last term is given. Use this formula. We can just simplify it. Just after that it is going to be substitution and then simplification only. So this will give you the answer as 1640 divided by 27 and that's going to be the answer for our question number 2. Coming to question number 3, here we have the nth term of a GP is 128. Okay, so given nth term of a GP is 128. So nth term is, it is like the last term. Okay, so it means L is what is given to be 128. We'll note down the things one by one. Okay, as it is given there in the question. So last term, I mean the nth term is what is 128. We are noting it. And then the sum of n terms is 255. See here, they are given sum of the n terms is 255. So that means they gave Sn is equal to 255. This also they gave here. And what next is given here? Continue. If its common ratio is 2, and next they gave the value of common ratio also, that is R is equal to 2. They gave common ratio is 2, R is equal to 2. Then what is that we need to find here? Then find the first term. That's it. Okay, very simple question. A is equal to what? First term is A. A is equal to what? This is what we are supposed to find here. Okay, so we know the value of L, Sn and R, and we need to find the value of A. That's it. Very simple. Okay, and again this is going to be what? Sum of n terms when the last term is given. See here, we have the last term here and Sn is also given. So that means we can use that Sn formula that is going to involve this sum of last terms. Okay, that means this formula is what we are supposed to use here. And that too, among these two, which formula we can use here to comfortable? Which one is comfortable to use here? See the value of R. R is equal to 2. That means R is greater than 1. Is it or not? So it is better if you use this second formula. Fine. Yes. Sn is equal to LR minus A by R minus 1. Let us use that formula here to solve this problem. Okay. Yes. So first of all, let us just note that formula down here. Sn is equal to LR minus A by R minus 1. We'll note down it here. So now we will have what? We'll just substitute the appropriate values. Now we have Sn. Sn is equal to what? Sn is 255. So 255 is equal to, what about LR minus A by R minus 1? L we know L is going to be 128 into R also we know it is going to be 2 minus A is what we need to find. So let us have A as A itself divided by denominator is R minus 1, that is 2 minus 1. That's it. Very simple, right? Yeah, fine. I'll put a line here. Next what we have is 255 is equal to, now we can do some simplification over here. So you'll have what? 128 into 2. 128 into 2 will be 256 minus A divided by, this is 2 minus 1, that's going to be 1. Fine. Okay, all right. Yeah, fine. Yes. Next I will have, let me continue it here. Okay, we have 255 is equal to, this is 256 minus A by 1. Anyways, it's going to become 256 minus A only. Simple, right? Yes. Yeah, okay, because anything divided by 1, the same value what we have the numerator itself will come there. So we'll be left with this step. 255 is equal to 256 minus A. By this itself we can easily tell the answer. So A will be what? 256 minus 255. So that means A is equal to 1. Yes. So the first term of this GP is going to be 1 is the answer for our question number 3. Next we have question number 4 with us. Another interesting question. If the sum of the first 6 terms of a GP, okay, the sum of the first 6 terms of a GP, how do we notate this? Sum of the first 6 terms of a GP, we'll notate it as S6. Is it or not? We'll write it as S6. Okay, yeah, fine. Because sum of first n terms means it is Sn. First 6 terms is it is S6. That's it. Okay. Is equal to, so this is equal to 9 times of, okay, 9 times of the sum of the first 3 terms. That is 9 times of means 9 into the sum of first 3 terms, that is S3. This is what they come to say. Fine. Yes. So S6 is equal to 9 times of S3. That's it. Okay. This is what we come to say here. Then find what? Find the common ratio of this GP. So we need to find the value of R. This is the question. Okay. All right. Yes. Yeah. Fine. And since we don't have the nature of, we don't know anything about the nature of R, we will default take this second formula itself to solve the problem. Okay. Yes. Yeah. Okay. Fine. Anyways, we have to use the Sn formula. So Sn, for which we can use this formula. Okay. All right. Yeah. Fine. Yes. Coming to the left hand side, we have S6. So that means here n value is 6. Correct? Yeah. Fine. So let us substitute n as 6 in that formula. Okay. So we have a into r power 6 minus 1 divided by r minus 1 is equal to 9 into. Now come there, again we have S3. S3 means here we have to use the same formula, but this time we have to take n as 3. Okay. So a into r power 3 minus 1 divided by r minus 1. Okay, fine. Yes. So we can cut the common terms here, both the left hand side and right hand side. We can cut a and a because in a GP the terms won't be non-zero. Same way we can also cancel these two values. See here, r cannot be minus 1 here. Okay, that we have to note it. R is not equal to 1. Okay, 1 or minus 1, usually that is how we take, right? Because we will not be able to use both the formulas, that's why. So especially r is not equal to 1, that is the way we assume it. And anyways, if this is the condition, r cannot be equal to 1 basically. Okay, fine. So fine, this is what we have. Now we will just take the leftover expressions. We have what? R power 6 minus 1 is equal to 9 into r power 3 minus 1. This is what we have. And now let us do something interesting here. Come to this left hand side. This left hand side I am going to write it in a modified way. Okay, yes. See our right hand side. Right hand side we have r power 3 minus 1. That is r cube minus 1. This is what we have here. Right. So now this left hand side also will try to do some kind of modification. Just closely watch here. Okay, what I am going to do here. I am going to write this r power 6 minus 1 as r power 3 the whole square minus 1 square. I can write like this, right? You can very well write like this, right? See here, r power 3 the whole square will be r power 6, and of course 1 square is 1. That's it. Okay. So this is equal to 9 into r power 3 minus 1. Okay. Now why I have written like this is, the reason is, now it has become in the model like a square minus b square. Now this became in the format a square minus b square. So what is a square minus b square? It is going to be a plus b into a minus b, and correspondingly you can understand a is r cube and b is 1. I hope you can understand this, right? So see here, this has become r cube plus 1 into r cube minus 1. That's it. Okay. So now this is equal to 9 into r cube minus 1. Okay. All right. Yes. Fine. Okay. Now what I can do here is I can cut these two terms also. So for this reason is what I just brought like this. Okay. So now simply we have what? We have simply, let me continue it here. Okay. Now we have simply r cube plus 1 is equal to 9. This is what we have. And now we can easily simplify this expression. So we have r cube is equal to 9 minus 1. That is going to be 8. So we have r cube is equal to 8. So r is equal to, what you will have? R is equal to 2 is going to be the answer. Very simple, right? Because r cube is equal to 8, in the sense this 8 is nothing but 2 cube, right? So that means r is equal to 2 is going to be the answer for this question, question number 4. I hope you are clear with this. So the only thing is we should make some kind of simplification, modification using algebra identity. So once that is done, you will be easily able to get the answer. At the same time, you should be sure with Sn formula. That's it. Okay, fine. So apart from this, it's going to be very, very easy question, and we are able to find the value of r. R is equal to 2 is going to be the answer for our question number 4. We have question number 5 with us. Here our question is, how many terms of the sequence 3, 3 square, 3 cube and so on are needed to get the sum as 120. This is going to be the question. So if you clearly see, this is going to be a geometric progression, and also we can easily get the values of A and also R, right? So A is going to be what? A is going to be 3 because that's the first term. And what about R? R is going to be the second term, 3 square divided by the first term, which is 3. So that means R is going to be simply 3 square by 3, which is going to be 3 only, right? So A is 3 and also R is 3. And also what next they are given? They gave that how many terms we need to get the sum, which gives the sum as 120. This is what they are asking. So that is, we also know what is the sum. That is Sn value also we know. Sn is what is this? 120. But they are asking how many terms we need. This is the question, right? How many terms they are asking? How many terms? So that means what is that they are asking us to find? We need to find the number of terms. That is the value of n is what we are supposed to find here in this question. So it's going to be a very easy question only. Yes, fine. We have the values of A, R, Sn, and finally we need to find the value of n. That's it. Okay. So we know Sn formula, right? We have got two formulas, the basic formulas. So which one using here will be appropriate? We can use this second formula, right? Okay. Yes. A into R power n minus 1 by R minus 1, because see the value of R here, R is 3, which is greater than 1. So it's better to use this formula. Okay, fine. Yes. So let us note down that formula first. Sn is equal to A into R power n minus 1 by R minus 1. I'm noting it here. And now we can substitute the known values. Okay, what are all the known values for us? We know Sn is 120. So 120 is equal to, we know A is 3, 3 into, we know R also, R is 3 power n minus 1 divided by, again R is 3 minus 1. That's it. Okay. So finally we will be getting 120 is equal to 3 into 3 power n minus 1 divided by, now what do you have in the denominator? We have 3 minus 1, that becomes 2. And now let me continue here. Okay. So now I will have this 3 power n minus 1 is equal to, now this 120 we have it here. Okay. This 120 will be now multiplied into, this 3 by 2 will come here to this side, the other side. It comes as what? It becomes into 2 by 3. Correct? Yes, because this side it is 3 by 2. When it comes here, it comes as 2 by 3. Okay. So this is what you will have. So you will have this one to be cancelled, and this will be exactly 3 4s are, so 40 times we'll have. So 40 into 2 will be 3 power n minus 1 is equal to 40 into 2 will be 80. So we'll have 3 power n is equal to 80. This will go like here as plus 1. So this becomes 81. That's it. Okay, fine. Yes. So that means we have 3 power n is equal to 81. So 81 I can write as 9 square. And once again I can write this 9 as 3 square and the whole square. So we have finally 3 square the whole square as 3 power 4. So that means this is enough for us to tell what is the value of n. N is equal to, we can compare the powers. 3 power n is equal to 3 power 4. So that means n is equal to 4. So how many terms are needed? So there are 4 terms needed. Okay, the first 4 terms if you take and add it, that will give you the sum as 120. So n is equal to 4. Number of terms we need is 4 is going to be the answer for our question number 5. Question number 6. Here we have 2 subdivisions. Let's work them one by one. So the first subdivision we have, if the second term of a GP is 2, okay. So given the second term of a GP, what do you mean by second term? Second term is T2, okay, yes. And hope you remember what is Tn formula in a GP, right? What is the formula? Tn is equal to AR power n minus 1, correct? And here we have term 2, that is T2. That means this will be equal to AR power 2 minus 1. That is going to be simply 1, or I can leave it as AR itself. Okay. So this value of AR is what is equal to 2. Fine. Okay. All right. Yes. Next, what is given? And the sum to infinity is 8. Sum up to infinity of this GP is going to be 8. We also know what is sum up to infinity. This can be given as what? We'll express this as A by 1 minus R. So the value of A by 1 minus R is what is 8. So this is what we have. Okay. So we have got 2 informations here. One is term 2. Second term is AR. This is equal to 2. And sum up to infinity, which is expressed as A by 1 minus R. This is equal to 8. Okay. Now we have got like 2 equations. We got 2 equations. And let's see what is asked for us to find. Find the first term of this GP. So this is going to be the question. So the first term, that means we have to find the value of A. A is equal to 1. This is this question. That's it. Okay, fine. So using these 2 equations, we have to do some kind of manipulations. We have to solve it, and then we have to get the value of A. This is going to be the objective. Okay, all right. Yes, fine. So now we have to find the value of A, for which what we can do is we'll try to do some kind of substitution. Okay, we'll take the expression from this equation and we'll substitute it here, and then we can solve for it. Yes, we can do like that, right? Yes. Okay, yes. So if we do like that, what happens is, yeah, from here we will start. Okay, AR equal to 2. From here we will start. I will do something. I will take the expression for R. R is equal to 2 by A. This is what I will get. Correct? Yes. From here, this equation, AR equal to 2, I will get what? I will be getting R equal to 2 by A. Okay. Now this expression, let me substitute it here. Fine, okay. I'll substitute in the second equation so that I will be getting what is. Now let me continue it here. Okay, fine. So I will be getting A by 1 minus R. Okay. In this place of R is what? Now we can put 2 by A. Okay. 1 minus 2 by A is equal to 8. This way I will have. Now see this equation, this entire equation has become in terms of A. Now we will solve for this equation. When we solve it, we can easily get the value of A. That's it. Okay. This is going to be the objective. Okay. Alright. So you have A divided by 1 minus 2 by A equal to 8. That's it. Okay. Fine. Okay. So we'll have A by 1 minus 2 by A. What about 1 minus 2 by A? This will become what? So 1 minus 2 by A will become, I can take the LCM, right? If I take it, I will have A into 1 will be A minus 2 divided by A. Okay, hope you understand that. A minus 2 divided by A, but I am going to do something here. The denominator of denominator A, I am going to take it to the numerator and it will simply become A square. Is the step clear? Yes, I will have A minus 2 by A. That A I am going to bring it to the numerator. It will become what? Already I have a A here. A into that A, that becomes A square. So simply we will have A square by A minus 2 is equal to A. Okay, fine. 8. Okay, this is what you will have. Now let me continue it here. Okay, so if I continue it here, I will have A square is equal to this 8 into this A minus 2 will be multiplied along with this 8. Correct? Okay, so you will have A square equal to 8 into A minus 2. So you will have A square equal to, I will just bring this 8 inside, so it will become 8A minus 16, because 8 into A is 8A, 8 into 2 is minus 16. Okay, so you have a minus here, so that comes along. And now I will bring these terms to the left hand side, so that you will have A square minus 8A plus 16 is equal to 0. Okay, alright. So finally we ended up with the quadratic equation, and if you carefully see this expression, this is nothing but what? This is nothing but what? You can, if I just want to give a clarity, I'll just write it in a modified way. Okay, so this is going to be A square minus 2 into A into 4 plus 4 square. I hope now you can understand this. Can you just recognize what is this? This is nothing but A minus 4 the whole square. Is it or not? Is it or not? Because see here, I am just modifying it as A square, A square. This minus 8A I am going to write as 2 into A into 4. Now see here, this becomes 8A, and the 16 I am writing as 4 square. Now you have this one in the format of A square minus 2AB plus B square. This is nothing but A minus B the whole square. So in the place of A you have A, and in the place of B you have 4. That's it. Okay, so you have A minus 4 the whole square is equal to 0. That means simply it becomes A minus 4 is equal to 0, and that means A is equal to 4. That's it. Okay, so the first term of the given GP is A is going to be 4, is going to be the answer for our sixth question, first subdivision. Okay, fine. I hope it is clear to you. A simple substitution, and then we have to go by solving the equation. You can easily get the answer. That is what we are following here to get the answer for this question. So A is equal to 4 is going to be the answer for the first subdivision. Yeah, coming here to the second subdivision, here we have the question. The first term of an infinite GP is 1. So what is given? The first term of an infinite GP is 1. That means A is equal to 1. Correct? Because first term is 1, A only, right? So that A is what is 1. Okay, and that too, here we have to note it. Here what is given? They gave that, they specified that it's an infinite GP. Okay, so infinite GP, and let's see what else is given here. And any term is equal to, in the GP, any term is equal to the sum of all succeeding terms. This is another important point we have to keep in our mind. Okay, fine. Yes. So be clear, this is what we have to strongly understand. Okay, so we are clear with what is the first term of the GP, and what next is given here. Here they gave any term is equal to, that is in the GP, we know what is the first term. Okay, first term is what? I'll just put some slots here. Okay, 1, 2, 3, 4, 5 and so on, because these are the terms of the GP. Okay, and among these I know the first term is what? It is going to be 1. We'll note it here. And any term is going to be the sum of all succeeding terms. What do you mean by succeeding terms? If I have the first term as 1, then The succeeding term will be what? All the other terms like second, third, fourth, fifth, these are all going to be succeeding terms of my term, first term. That's it. Okay, fine, yes. Same way, if you take the second term, what will be the succeeding terms of second term? They are nothing but term 3, term 4, term 5, term 6 and so on. Yes, okay. Succeeding means the terms which are going to follow the given particular term. Okay, fine, yes. If I take the first term, my first term is 1. Okay, that is okay. My succeeding term, what are my succeeding terms of my first term? All the other terms that are following my first term. Okay, that is term 2, term 3, term 4, term 5. These are what? Okay. Now, what point they are coming to say here is, any term is equal to the sum of all succeeding terms. That is, I know that my first term of this GP is 1. Fine, okay. And after that, what else I can tell here is, the sum of all the other remaining terms that is going to follow this one is going to be equal to the same 1 itself. This is what they are coming to say. Yes, okay. That is, the sum of all the other terms. I don't know what are my term 2, term 3, term 4. Nothing I know. I have no idea about what these terms are. But according to this condition, what they are coming to say is, sum of all these terms is going to be what? It is going to be 1. This is what they are coming to say. So, any term is equal to the sum of all succeeding terms. So, my succeeding terms are going to be whatever terms it is. But their sum is going to be equal to the term which I have here, 1. This is what they are coming to say. That's it. Okay, fine, yes. And this applies to the other terms also. If I take the second term, I don't know whatever the second term will be. But what else I can tell? The second term is something, and what else I can tell is the terms that are going to follow my second term, that is term 3, term 4, term 5, term 6 up to infinity. If I add everything from term 3 till infinity, if I add everything, that entire sum will be equal to the second term. This is what that point they are coming to tell here. Fine, okay, yes. Okay, alright. And in this case, you can very easily tell what is S infinity also, correct? S infinity also you can tell very easily. How you can tell it? It's going to be very easy. I know my first term is 1. And what else I know? I know except this first term, the sum of all the other terms in this GP is going to be another 1. So in this case, what will be S infinity? S infinity will be the sum of what? It's going to be the sum of the first term along with all the other terms. Is it or not? Sum of all the terms is what is up to infinity is what is S infinity, right? I know my first term is 1 plus this is going to be another 1. I mean till the end it is going to be 1. So 1 plus 1 is going to be 2. That's it. I can tell it here itself. So I know clearly what are all the things I come to know. I know the first term is 1 and also I know sum of infinity terms is going to be 2. Sum up to infinity of this GP is going to be 2. How is the 2 coming? The 2 comes from this meaning, okay? Because the first term is 1 and the other term, sum of all the other remaining terms is going to be another 1. So 1 plus 1 is going to be 2. That's it, okay? You may wonder how it is possible, since this is taking up to infinity, how it can be 1, okay? This is following from the given condition of the question only, because in question itself we have defined that like that way only, okay? Yes, fine. So first term is 1 and the sum of the other all remaining terms is going to be same as this term, because the other terms are succeeding this term, right? That's why, okay? If this is 1, all these are going to be 1. So the sum of all these terms is the entire terms itself will be 1 plus 1, that is going to be 2. That's it, finished. Okay, yes, all right. And we know the meaning of sum infinity, right? Sum infinity means sum of all terms up to infinity. And we also know the formula, right? What's the formula? We know the formula is A by 1 minus R is equal to is what is 2. Okay, fine, yes. And we know the value of A is 1, right? Because A is equal to 1, that is given in the question itself. First term is 1. So now I can substitute it here. So when I do that, I will be getting 1 by 1 minus R is equal to 2. So that means I will be getting what? I will be getting 1 minus R is equal to 1 by 2, because I can bring this 1 minus R there, the 2 will come here. So now I will have R is equal to 1 minus 1 by 2. So that means this will be equal to 1 by 2. So finally we are able to get the value of R also. So A is equal to 1 and R is equal to 1 by 2. So both these values we are able to get. Okay, fine, yes. Finally, what is it they are asking? Find the GP. This is the question. Okay, we need to find the GP. So what is the GP? GP means we will have to write the first few terms of the GP. Okay, fine, yes. So what can be the other terms? We know the first term is 1. And so second term will be what? 1 into 1 by 2, which is going to be 1 by 2. and third term will be 1 by 2 into 1 by 2, that's going to be 1 by 4, and fourth term will be 1 by 4 into 1 by 2, that's going to be 1 by 8, and into 1 by 2, that's going to be 1 by 16. So these are the terms of my GP. Okay, so this is going to be my GP. So yes, this is going to be the answer for our second subdivision. So such an interesting question this is. More than knowing the formula or anything, we have to be very clear with the logic what they are defined. So once we are clear with that, we are able to crack that, we can easily solve this question. So that is what is really important here for this question for us to understand. Okay, yes, so I hope it is clear to you. Once again, you can again see this. Okay, just come try to put that settle in your mind. Okay, then only you can understand it properly. Okay, you can even take some time to understand it. So yeah, it will take some time for you to settle. So yes, so be clear with this thing. So anyways, 1 by 2, 1 by 4, 1 by 8 and so on, this is going to be the GP. So yeah, these are going to be the answers for our question number 6. We have question number 7. It's going to be a very easy question only. So here we have evaluate the value of 3 into 3 power 1 by 2 into 3 power 1 by 4 into 3 power 1 by 8 into and so on, and it goes up to infinity. Okay, yes, so we have to find or evaluate the value of this given product. This is going to be the question. So yeah, of course, what we can do here is we can write this as 3. This is 3 power 1, correct? Multiplied with 3 power, this is going to be 1 by 2. I'm going to write the fractions as it is, okay? Into 3 power 1 by 4 into 3 power 1 by 8 and so on. This goes up to infinity. Fine, okay. And we very well know the axiom of exponents. What do we know about the powers of the axioms of this exponents? We know that when you have the same base raised to different powers, and when we have multiplication, what we can do with the powers? We can simply add the powers, is it or not? So we can add the powers. So the powers, when you add it, you will be having 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on. This is what you will have. So if you clearly see, this is going to be the expression what you have in the power is going to be what? It is going to be a geometric series, right? This is a geometric progression. You have an addition here. So we have a sum up to infinity of this GP. Okay, yes. So first of all, let us do something. We'll separately find the sum. Okay. So this is the sum up to infinity of what term? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 and so on. This is what we have here. So first of all, we need to find the sum up to infinity of this series. Okay, we will find this, then we can substitute it back to this power. Okay, yes, all right. So yeah, first of all, we'll just see about this geometric progression. Here, what is the value of A? A is going to be simply 1 because first term is 1. And also it is very easy for us to visualize what is the value of R. R is going to be second term divided by first term. So 1 by 2 divided by 1, that's going to be 1 by 2 only. So now we can very easily find what is S infinity. S infinity, the formula we know, A by 1 minus R, right? A divided by 1 minus R. So this will give you 1 divided by, because A is 1. So 1 divided by 1 minus R. R is 1 by 2. That's it. Fine. Okay. So we will have what? We will have 1 by, this will give you 1 minus 1 by 2 will give you 1 by 2. So that means 1 by 1 by 2 will be simply 2, because this goes to the numerator, it becomes 2. So that means this entire sum will be equal to what? It is equal to the value of this entire sum is 2 is going to be the value. Now we can very well substitute this one here in the power of 3. Okay, yes. So we have 3 power, this very long expression we have, this infinite sum. This infinite sum's value is what is this 2. So we can substitute it here, 3 power 2 you will have. So 3 square, this is 3 square. So value of 3 square is going to be 9 is going to be the answer. And yes, that's it. This is going to be the answer for our question number 7. So the answer for this expression, this product is going to be, this infinite product is going to be, the answer is 9 is going to be the answer. Okay, yes, fine. Next is question number 8 with us. Here the question is, find the first term of a GP whose common ratio is 3. Okay, so there is some GP and they gave the common ratio of the GP is 3. So that means R is equal to is what is 3, is it or not? Because common ratio is R, so R value is equal to 3. Last term, okay, last term is 486, so that is L is equal to 486, and the sum of whose terms is 728. Okay, so sum means Sn, so Sn is equal to 728. So all these things are given, and what is that we have to find here? We have to find the first term of the GP, that is find the first term means we have to find the value of A. A is equal to what? This is going to be the question. Okay, all right. So that means to solve this problem, we can take the help of which formula? We can take the help of Sn formula, which involves the last term. Okay, yes. And that too, here we have got two formulas here. Which one we can take here? Which one, using which one will be very appropriate here? So we have to see the value of R, correct? Okay, R is equal to 3. So that means we can better use this second formula to solve this problem. Okay, all right, yes. So we can use the second formula. So when we use the second formula, we'll just note it down first. So we have Sn is equal to LR, okay, LR minus A divided by R minus 1. This is going to be the formula, right? Yes. So we can use this formula to solve this problem because we have all the values available here in the question itself. That A value alone, we have to find it. Okay, yes, fine. So Sn value is going to be 728. So 728 is equal to here L into R. So 486 into R is 3 minus A. A is what we have to find, divided by R minus 1, that is 3 minus 1. Yes, is it clear? Fine, okay. Now what next we can do here is we can just do it like 728 is equal to 486 into 3 we have to do, correct? We can do 486 into 3. So this will give us what? This will be giving us 3 6 are 18, 1 carry, 3 8s are 24 plus 1 is 25, 2 is carry, and 3 4s are 12, 12 plus 2 is 4. So 1458 minus A divided by, here denominator we have 3 minus 1, this is equal to 2. Okay, I'll continue here. So what next I will have here is I can just take this 2 to the left hand side. So this will be multiplication. Okay, so 728 into 2 is equal to 1458 minus A. This is what we will be getting. So now I can multiply these two numbers. 728 into 2 will give you how much? 28 2s are will be 56 and 7 2s are will be 14. So 1456 is equal to 1458 minus A. From this itself we can tell. So from this number you minus A, you get this. So from this itself we can tell very easily. A is equal to what? A is equal to, it's the difference between these two numbers, 1458 minus 1456. That will be 2 is the answer. So A is equal to 2 is going to be the answer for our question number 8. I hope it is clear to you. So we are just using this formula, okay, though this Sn formula. So to solve this, so we are just taking all the other values available in the question. That A alone is missing. Once you solve this equation, you come to get the value of A, and A is equal to 2 is going to be the answer for our question number 8. Question number 9 with us. Here our question is, if the first term of a GP is 5 and the sum of the first 3 terms is 31 by 5. Okay, all right. So let's note the things. So here we have the first term of a GP is 5. So that is, we have A is equal to 5. That is given here. And next, what is given here? The sum of the first 3 terms. Okay, that is, the sum of the first 3 terms is 31 by 5. Okay, so that means first 3 terms means what terms we have to take? We know how to express the first 3 terms, right? Okay, and that too, this 3 is not a very big number, so it is not necessary for us to use Sn formula. All right, yes. So in that case, let us just notate the terms itself. Okay, so we know the first term is 5. Okay, so that is T1 is going to be 5. Now what about T2? T2 will be what? T2 will be nothing but what? It will be 5 into R, because R is a common ratio, right? And T3 will be what? T3 will be 5R into R, which means 5R square. Okay, so that means we can notate the first 3 terms of this GP with these notations. Okay, 5, 5R and 5R square. We can notate like this. So in this sense, what happens? What will this statement come to deliver? We will be having 5 plus 5R plus 5R square. This is what is equal to 31 by 5. We can have it like this, right? Correct? Yes, this will be available, right? So this way we can take it like this. Now what we have to do here is find the common ratio. This is the question. So that is, we have to find the value of R. R is what? This is what they are asking in the question. So all we have is A equal to 5. So with that, we are just framing the first 3 terms, T1, T2, T3, and also it is given the first 3 terms, the sum is going to be 31 by 5. So we are adding everything, equating it to 31 by 5. So now we got an equation which is in terms of R, Now we have to find the value of r. This is the question. Find the common ratio. So that means we have to find the value of r only. That is the question. So once you solve this equation, we can easily get the value of r. That's it. Okay, fine. Yeah, okay. So now let us see how can this equation be solved to get the answer. Okay, fine. Yeah, okay. So first thing what we can do here is, I will first of all bring this phi to the other side, so that it becomes what? This becomes phi r square plus phi r is equal to 31 by 5 minus 5. This become like this. This will become like this, correct? This phi goes here, it goes as minus 5. Okay. Now once again, phi r square plus phi r will be equal to, now can you simplify this right hand side part? This will give you how much? This is 31 by 5 minus 5. So I can multiply 5 5s are 25. Then what I can do? I can just do this 31 minus that 25. I hope you can understand that. I will do 31 minus that 25. So this will give you how much? 31 minus 25 will be 6. So you will finally have 6 by 5. That's it. Is it or not? Yes. Is it clear? Fine. I hope you can understand this step very clearly. So you have phi r square plus phi r is equal to 6 by 5. This is what you have once after simplification. Now once again what I will do here is, I will take this phi again to the left hand side. So this will come as multiplication. Okay, you will have 5 into phi r square plus phi r is equal to 6. This comes like this. And what next I can do is, I can just multiply this 5 inside. So I will have 25 r square plus 25 r. Then what next I will have is, I will have minus 6 is equal to 0. I hope you can understand this step also. Why? Because this 6 what you have on the right hand side, that I am taking to the left hand side, it comes as minus 6 is equal to 0. That's it. Now if you observe, we have got a quadratic equation which is in terms of r. Now we need to solve this equation. We can easily get the value of r. That's it. Okay, fine. Yes. So this is what we are expected to do here. Now if you see, we have to solve this quadratic equation, and we can take the help of factorization to solve this equation. Fine. Okay. So how to do that factorization? I have to first multiply these two numbers. 25 into minus 6. So 25 6 are, it is going to be 150, right? So you will have minus 150. Why? Because you have minus 6 here. Remember that. Okay. So plus 25 into minus 6, it will be minus 150. Now you have to factorize this minus 150 in such a way that the product of the two numbers is minus 150 and the sum of the two numbers is plus 25. Got it? Yes. Okay. So in that way we have to factorize. So we will start from small numbers. Okay. So I can do it with two tables. 2 into 75 I can do. Correct. Okay. Because I need to get minus 150. I will take the smaller number as minus and bigger number as plus. Then only I will be getting the sum also as positive. That's why. Okay. Fine. Yeah. Okay. So this pair is not suitable. Why? Because if you add it, you will be getting what? Plus 73 only you will be getting. So this is not okay. And what next I can do? I can go for minus 3 into plus 50. Can you just check it? Because 3 into 50 will be 150. That is okay. But sum again it will not be okay. And next I can go for 4 tables. But 4 it will not be divisible. I can go for 5 tables, right? Minus 5 into plus 30. Can you just check this? This pair seems to be okay, right? Minus 5 into plus 30 will be minus 150. And at the same time, the addition minus 5 plus 30 will be plus 25. Success. So that means you can take this pair. This is going to be valid. So now I will take these two numbers here. 25r square minus 5r plus 30r minus 6 is equal to 0. Fine. Okay. Yes. Next I will just take this 5r as common here. So I will have 5r minus 1 here for the first two terms, because I will just factor 5r outside from this. So I will have 5r coming out. So 5r, and here I will have 1 as common. Then from these two terms I will take 6 to be common factor. So if I take it, I will again have 5r minus 1 is equal to 0. So now when I solve for r, I will just take again this 5r minus 1 as a common factor. I will have 5r plus 6 is equal to 0. Now I can individually equate these two factors to 0. I will get 5r minus 1 is equal to 0, or 5r plus 6 is equal to 0. So from this one I will be getting r equal to 1 by 5. Correct? Or from here I will get r is equal to minus 6 by 5. I hope it is clear to you. Why? Because here this is minus 1, this goes here as plus 1 by 5, and this is plus 6, this goes there as minus 6 by 5. So these are two solutions you have for r equal to 1 by 5 or minus 6 by 5. These are going to be the solutions for, or the values of r for this question. So these are going to be the answers for our question number 9. Question number 10 with us, another interesting question we have. So here the question is, the sum of the first 3 terms is to the sum of the first 6 terms. Okay. So the sum of the first 3 terms is to the sum of the first 6 terms is going to be how much? It is recorded as 125 is to 152. Okay, let us note it. So sum in the sense it is going to stand for the sum S. Okay, so the sum of first 3 terms, that means how do we represent it? We'll write as S3. This value is to the sum of first 6 terms, that is going to be S6. Okay, so this is to this is equal to, this is what is given to be how much? It is given as 125 is to 152. This is what it is given. Fine. Okay. All right. Yeah. Okay. Now in this case, find the common ratio of the GP. So we are supposed to find the value of R. That's it. Very simple. Fine. Okay. So since this problem is based on sum, we have to use the SN formula. Let us use this formula. Okay. In default, we will use this formula to represent SN. And yeah, we are going to use the same formula here. And of course, we don't have any idea about what is the first term of this GP. Nothing is available. It is not given here in the question. But anyways, the problem is independent of the first term of this GP. So in that case, let us directly substitute this formula here. Okay, yes. Yeah, okay. If you do that, what happens is, come here S3. Okay, what is the value of S3? First of all, S3 will be, so in the place of N, we have to take it as 3. That's it. Okay, because SN formula is what we have there. Here we can take N is equal to 3. So if you do so, what happens is, this S3 expression will become A into R power 3 minus 1 divided by R minus 1 is 2. And here S6 will become what? This becomes A into R power 6 minus 1 divided by R minus 1. So this is what is equal to what? This is equal to 125 is to 152. This is what we have here. Fine. Okay. And since this is ratio, this is like a division only, right? I can cut the common terms. So I'm just cutting this numerator A and A, denominator R minus 1 and R minus 1. Okay, fine. So we are just left with these 2 terms. Okay, so that means we are having R cube minus 1 divided by R power 6 minus 1 is equal to 125 by 152. Let me write like a division. Okay, all right. So if you write like a division, this is the structure you will be getting. And what next you can do is, if you remember few problems before, we just factorize this R power 6 minus 1. We got the same way, like how we got here, we are getting here. The same way there also we got, right? How we factorized that expression, the same way we are going to factorize this expression here also. Fine. Okay. So how am I going to write this? This R power 6 minus 1, I am going to write it as, first of all, I will come to the numerator, R cube minus 1. This R power 6 minus 1, I am going to write as what? R cube minus 1 into R cube plus 1. I hope you remember how we did this. So you can refer that previous questions, like, okay, previous few problems ago, we had a similar, we had the same expression there repeated. So there how we solved, we just resolved it, factorized it the same way I'm factorizing here also. Okay, let me not again explain it from the beginning. So it's very simple to understand. This R power 6 is like R cubes whole square, and this 1 is like 1 square. Okay, so I'm just using A square minus B square identity to expand this. Okay, so that it becomes A minus B into A plus B. Okay, why? Because now it will be easy for me to cut these 2 terms. That's why. Okay, so finally we have what? We are having what? We are having 1. So it is like numerator we have only 1. Okay, so we have 1 by denominator we only have R cube plus 1. So R cube plus 1. This is equal to, now come to the right hand side. Right hand side we have 125 by 152. Okay, 125 by 152. This is what we have, and we have to find the value of R, right? So let me do another thing here. Let us take reciprocal on both the sides. Fine. Okay, we'll take reciprocal, so that left hand side will become simply R cube plus 1 and right hand side will become 152 by 125. Okay, all right, this is how it becomes. And what next I can do is, I will have R cube is equal to, let me take this plus 1 to the other side, it becomes minus 1 there. Okay, it becomes 152 by 125 minus 1 it becomes. So now when I take the LCM, what happens? It becomes 125 into 1, it becomes 152 minus 125 whole divided by 125. This is what it becomes. Fine. Okay, all right. And what next is r cube is equal to, so now come to the numerator simplification. This will be 152 minus 125. So what is 152 minus 125? It is like 52 minus 25, right? Because this 100 and 100, they will be gone. So I have 52 minus 25 will be 25 plus 2, 27, right? So we will have 27 divided by 125. This is what you will have. And once again, I can rewrite this 27 by 125 as, see here, watch closely. This 27 can be rewritten as 3 cube, and this 125 can be rewritten as 5 cube. You can do that, right? Yes. 3 cube by 5 cube, and finally I can write as 3 by 5 the whole cube. That's it. Okay, fine. So that means what we are getting is r cube is equal to 3 by 5 the whole cube, which means r is equal to what? R is equal to, you can just compare the numbers, okay? 3 by 5. So that means the common ratio, I mean the value of r is going to be what? Find the common ratio. That's the question, right? R is equal to what? R is equal to 3 by 5 is going to be the answer for this question number 10. We have question number 11 with us. Here we have evaluate summation n runs from 1 to 50 of 2 power n minus 1. So this summation is what we have to find. I hope you know the meaning of summation. Summation means it is going to take the addition values, okay? So we have to sum the values of this expression where n is going to take values from 1 to 50. This is the meaning, okay? Fine, yes? Okay, yes. So first of all, we'll try to expand this, okay? So when we try to expand this, what will happen is, first of all, we have to substitute the values of n starting from 1 till 50. This is what we are expected to do here. Okay, fine, all right? Yes. So now carefully we will substitute the values of n one by one. Fine, yes. So we have to first substitute what value? We have to take n as 1 here. So here in this expression we will put n as 1. Okay. So what we'll be getting here is, we'll get 2 power 1 minus 1. This is what we'll have. Okay, then put a plus. Next, what you will have? Next, we have to take n is equal to 2. Fine, okay. So we'll take n is equal to 2. That means you will have 2 power 2 minus 1. Fine, okay. So only at this place you have to substitute the value of n. Okay, first we took n as 1. So we got 2 power 1 minus 1. Here we then took n is equal to 2. So our expression became 2 power 2 minus 1. So plus, next what you have to take? We have to take n is equal to 3. Okay, one by one we have to take the values. Okay, n equal to 1, 2, 3, like that we have to take. So when n takes the value 3, this expression becomes 2 power 3 minus 1 and plus, and so on. This goes and goes. And this will go till how much value? Till what value it will go? It will go till n is equal to 50. Fine, this is the meaning. Okay, all right. So I have to take n is equal to 50 here. So when n takes the value 50, this expression becomes 2 to the power 50 minus 1. So that means the expansion of this expression is going to be this expression only. I hope now it is clear to you. Okay, this is the meaning of that summation, and we have expanded this, and this expanded version is what you see here. Fine, okay, all right. Yeah, okay. Now we will segregate the terms. We'll just segregate the terms. Okay, fine, all right. Yes. So how we can segregate the terms? So we will collect the 2's powers first. Okay, 2 power 1, 2 power 2, 2 power 3, like that we have the terms, right? 2 powers, right? So we will first of all segregate the terms. We'll just write them to be 2 power 1 plus 2 power 2 plus 2 power 3 and so on till the last term, which is going to be 2 power 50. Okay, yes. I will just put these terms inside one bracket. Fine, okay. And next what I'm going to do is, listen carefully. Next what I'm going to do is, I'm going to collect these minus ones. Minus 1, minus 1, minus 1, minus 1 and so on up to this minus 1. So totally how many minus 1s are there? How many minus 1s are there? Minus 1, minus 1, minus 1. There are 50 minus 1s are there. Is it or not? Is it or not? So that means there is going to be 50 minus 1. So I can just take them as minus 1 times of 50. We can put like this, right? Yes, you accept this, right? This is easy for you to accept. Why? Because we have got minus 1, minus 1, minus 1. Till how many minus 1s are there? All these terms are minus 1 only. But how many minus 1s are there? There are 50 minus 1s. How am I telling it is 50? Because our summation for n is running from 1 to 50. So our n values n is going to take the values from 1 to 50. So that many times this minus 1 will also be repeated. For that case, I am just writing minus 1 into 50. I hope the meaning is simple for you to understand. Okay, all right. Yes. Now coming back to this summation. What is that here we have? Here we have 2 power 1 plus 2 power 2 plus 2 power 3 and so on up to 2 power 50. This is what we have. Correct? Yes. Now can you closely watch what we have here? This is nothing but a GP. This is a geometric progression. Is it or not? So here we see a geometric progression, and for this geometric progression we have to find the sum of the terms. Fine. Okay. All right. That is, we need to find what? We need to find the value of Sn. This is what we have to find here. So let me do something here. I will separately work out this summation here. Fine. Okay. I think this space is enough for us to do the workout process. So let me note down this 2 power 1, 2 power 2 plus 2 power 3 up to 2 power 50. So all these values we have to add. And kindly check how many values you have here. There are 50 values here. Is it or not? So that means number of terms is going to be how much? Number of terms n is going to be 50. This is okay. And what other values we want to find the sum of the elements, sum of the terms of a GP? What other values we want? We need the value of n. That is okay. What other values we want? We want the values of a and also r. Correct? Yes. So we'll note down the value of a. A is going to be simply 2 power 1. 2 power 1 is going to be 2. Correct? Because a is the first term. First term is 2 power 1. That's nothing but 2. And we also need the value of r. R also we want. So how to find the value of r? As usual, we can take the first two terms. Term 2 divided by term 1. I can divide, I will get the value of r. Is it or not? So term 2 here is what? 2 square divided by term 1 is 2 power 1. This is what we have, right? So that means this is nothing but what? This will imply r is equal to what? This is 2 square 4. This is 2 power 1 2. So you will have 4 by 2 to be again 2. So that means we have n is equal to 50, a is equal to 2, r is equal to 2. Now for this GP, we have to find the value of sum of the terms. Okay. So sum of the terms, we'll just recollect the formula. What is the formula? Sn is equal to, let us use this formula. Okay. A into r power n minus 1 by r minus 1. Why we are choosing this formula? Why? Because see the value of r here. R is greater than 1. R is equal to 2, right? That means r is greater than 1, right? So that means we can use this formula to find the Sn value, okay? And here we have what? We have 50 terms, so S50 will be equal to A value is what? 2, so 2 into r power n, that means r power n is going to be, r is basically 2, right? So 2 power n is 50 minus 1 divided by r minus 1, that is 2 minus 1. Correct? Yes? Okay, so this is what we have. So this will be equal to, anyhow denominator will become what? Denominator will simply become, this will become 2 minus 1. So 2 minus 1 is going to be 1 only, correct? Okay, so you will have 2 into 2 power 50 minus 1. This is what overall we have here. Okay, fine, yes. So that means the summation, this summation, when you simplify, what answer you are getting the answer to be 2 times of 2 power 50 minus 1. This is going to be the answer. Okay, all right. So now we can substitute that value here. We can do that, right? So this is equal to, this expression's value is what we obtained here. What we got here? We got it to be 2 into 2 power 50 minus 1. Okay, and here what we have? Here we have minus 1 into 50. So minus 1 into 50 will be nothing but minus 50 only. Is it or not? Yes. Fine. So this is going to be the expression, and still if you want to simplify, you can even go for that. So what we can do here is, we can multiply this 2 inside. We can do that, right? So when you multiply this 2 inside, you will get 2 into 2 power 50 minus 2, because this 2 into 2 power 50 I am writing here, and 2 into minus 1 is what is this? Minus 2, and we have a minus 50 here, that I am writing here. Fine. Okay, all right. And what next we can do? Still if you want to simplify, what we can do here is, I can just write this 2 as 2 power 1. So this is like 2 power 1 multiplied with 2 power 50. Is it or not? So when you multiply, what happens? The power will be getting added, because this 2 power 1, this 2 power 50. When you have the same base multiplied, the power will be getting added. So what happens? 2 power 1 plus 50, that will be 51. And here I have minus 2 minus 50. That when you put them together, what happens? That becomes minus 52. Fine. Okay. So that means 2 power 51 minus 52 is going to be your final overall answer for this given expression, and that is going to be the answer for your question number 11. Next is question number 12 with us. Here we have, find the sum of n terms of a series whose mth term is, okay, whose mth term is 2 power m plus 2m. Okay, this is going to be the question. So we have to find the sum of n terms of a series, and they have defined the mth term. Okay, so for that series, any mth term is defined by 2 power m plus 2m. This is what is given. Fine. Okay. All right. Yes. So this is also like the previous question. Okay, there we had a summation, right? Question number 11, we had a summation. The same way here also they have constructed this question. Okay, we'll just try to represent this question also in the same symbolical way. Yes, shall I do that? Yes. Okay, fine. Yes. So here we have to evaluate. Simply we have to evaluate. What we have to evaluate is we have to find the summation of, okay, summation of m runs from 1 to n. Fine. Okay, carefully you try to understand this. Summation m runs from 1 to n. That is, m is taking the value from 1 to n. Why up to n? Because they are asking us to find the sum of n terms. Okay, this we have to note down. Okay, sum of n terms we have to find, and whose nth term is defined as what? 2 power m plus 2m. Okay, that we'll just put here, 2 power m plus 2m. So that's all. This value is what finally we have to evaluate. Fine. Okay. All right. Yes. Yeah. Okay. And as usual, what we will do here also, we'll try to do the same kind of substitution process. Fine. Okay. All right. Yes. Okay. So what we can do here is we'll try to do the same substitution process. How we can do here is, so I'll put an equal to, I will take the values for m from starting from 1. Okay. So now take m is equal to 1 here in both the places, because this is our given expression, and inside our expression wherever m comes, there we have to put the value 1 first. Okay. Yeah. Okay. So when I take m equal to 1 here, what happens is you will have 2 power 1 plus 2 into 1. Okay. This is not 2.1, just that means like 2.1 means 2 into 1. Okay. So I'm using that point to define the multiplication process. Okay. All right. Yes. Plus, next we have to take m is equal to 2, right? Okay, because m is equal to 2 is the next value, right? So we'll take m is equal to 2. So that means we will have 2 power 2 plus 2 into 2. Continue. Next we have to take m as 3. So we'll have 2 power 3 plus 2 into 3, and so on and so on, up to what value we will have is plus 2 power n plus 2 into n. This is what we'll have. I hope you can understand this. Okay, this goes till what value? Till the last term. And what is the last term? Last term is n, right? So that means m will take the value n, and m is equal to n is going to be the last value. I hope you understood this, right? Okay, that is m equal to 1, that's the first value, m equal to 2, that's the second value, m equal to 3 is the third value, and so on. It will go till m is equal to n, and that is the last value. Till that we have to find the summation. Why we are stopping with n? Again, the thing is, we are asked to find the sum of the first n terms. That's the reason. Okay, that's why we are taking from 1 till n. Okay, all right. And yes, here again I am going to use the same kind of segregation way. Okay, we'll just try to segregate the terms. How we can segregate? We'll just take the 2's powers first. Okay, so when I take 2's powers, we'll have 2 power 1 plus 2 power 2 plus 2 power 3 and so on, up to the last term is 2 power n. Okay, so I'm collecting all the 2's powers terms, I'm just putting in one bracket. Then plus we'll take these terms next. Okay, which terms? 2 into 1, 2 into 2, 2 into 3, up to 2 into n. This will take in another braces. Okay, another bracket. Okay, 2 into 1 plus 2 into 2 plus 2 into 3 plus up to 2 into n. Remember, this point does not denote the decimal point. This means a product, multiplication. Okay, fine. Yes, in order to save the space, I'm just writing like that. Okay, that's the reason I'm keep on repeating it. Okay, fine. Yes, yeah. Okay, this way we got it. Fine. Okay, all right. And once again, coming back here, this is actually what? This is nothing but, this is a geometric progression, and here we have to find the sum of the first n terms. That's it. Okay, very simple. Okay, fine. Okay, now what we will do here is, I'll just continue the same way. Okay, because this is not going to be very much complicated, so for that reason let me continue the same way. Okay, this notations I will place here in this space, and this notations we'll use here to continue. Okay, all right. Yes, yeah, fine. Yeah, coming here, as we discussed, this is a geometric progression, and here what is the first term? First term is 2 power 1, which is going to be 2. And what about the second, I mean the next r value? What is the common ratio of this? R is equal to what? R is equal to second term divided by first term, right? Here also we are getting the same way how we got in the previous problem. Okay, so we are having r value to be what? Term 2 divided by term 1. So again we will be getting 2 square by 2 power 1. That's nothing but 2. And n is what? N is n only. Fine. Okay, so that means here we are supposed to find the value of Sn. So again we'll use the same formula for Sn. Okay, Sn formula. Which formula we have to use? A into r power n minus 1 by r minus 1. Okay, I'm telling orally. Just make it understand. Okay, fine. Yes, a into r power n minus 1 by r minus 1. Why? Because the value of r is going to be 2, that is greater than 1. That means we are using that particular formula. Okay, so I'm continuing here. Let me continue it here. Okay, yes, so continue. These are just notations. Okay, these are notations. Please you don't have to take it along with this. With the flow you can take it like this. So this is for your understanding notation. I'm just writing like this so as to use the formula. Okay, all right. Yeah, using it here, what happens is a into, that is 2 into, what about r power n? R is 2, so 2 power n minus 1 divided by r minus 1, which is 2 minus 1. I hope you are able to understand this. Okay, this is going to be this expression, and yeah, plus coming here what do you have here? Here what else we have here? Here we have, first of all we can do one thing here. Here I can take the 2 as a common factor outside, correct? Because in each of these terms we have got 2. Fine. Okay, so once you take the 2 outside, you will have 1 plus 2 plus 3 plus so on up to n. So this is what we will have. Yes, correct? Yes, I hope you can understand this. And now next what I can do is plus 2 into, we know this well known notation, right? 1 plus 2 plus 3 plus up to n. This is actually what? This is nothing but the sum of the first n natural numbers, correct? Yes, so sum of first n natural numbers is what you have here, and we know the notation, right? What is the notation? It is nothing but n into n plus 1 by 2. That is the notation. And okay, even if it is not okay for you, you can just treat this as an arithmetic progression. Is it or not? We know the sum of n terms of an AP, right? That formula also we know, right? What is the formula? It is better to remember that also. Okay, fine. Yes. Why? Because when we do this process, this AP's idea will also be included. Okay, that is also possible. So we should not be thinking independently. Okay, if you are working a GP problem, don't fix yourself to only GP only. Okay, we can even involve, this can even involve AP's concept also. So kindly remember that AP's formula. Okay, if you want, I can even just recollect the formula. I'll just help you to recollect the formula. So what is the formula? Sn formula is what? In an AP. Okay, let me write it in the side. Okay, in an AP, what is Sn formula? Sn is equal to n by 2 into a plus l. I hope you remember the formula, right? Okay, why I am choosing this formula is we know the first term, we know the last term, that's why I am taking this one. Okay, fine. Yes, so now let us use this formula here. So what happens? 1 plus 2 plus 3 up to n. So this will be nothing but what? This will be nothing but sum of n terms of an AP, and here we can use this formula very well. Yes, so n by 2, so n by 2 into, what about this a plus l? What is a? A is the first term, which is 1, plus l is the last term, which is n. That's it. Okay, fine. Now I can cut these two terms now. So finally what we will be left with? Again come back here. Here we have 2 into 2 power n minus 1 divided by, this is 2 minus 1 is going to be simply 1. So that means you will overall have 2 into 2 power n minus 1, and here we are left with plus n into n plus 1. Why? Because this 2 and this 2 are getting cancelled. So you will have n into, this is n plus 1. Okay, I am writing it as n plus 1. And yes, this expression, this overall expression is what we are getting the answer for this given question. Okay, alright, yes. So what is the answer? 2 into 2 power n minus 1 plus n into n plus 1. So our final answer is now in terms of what? It is in terms of n. Why? Because we are asked to find the sum of n terms only. That's the reason. Okay, so 2 into 2 power n minus 1 plus n into n plus 1 is going to be the answer for our question number 12. Next we have question number 13 with us. Here the question says find the sum of the following series up to n terms. We have to find the sum up to n terms of the given series. So we have got 3 subdivisions here. The first among them is what we have working out. Let's work them one by one. Okay, the first subdivision, the question here is 7 plus 77 plus 777. So this is a series going like this. I hope you can understand what pattern this series is following, and using that pattern you yourself can identify what will be the next term coming in this series. What will be the next term? That's going to be what? 7777. That's it. Okay, first term we have 1 7, second term we have 2 7s, third term we have 3 7, fourth term will have 4 7, and fifth term will have 5 7s, and so on. This will be going like this. And for this series we are expected to find the sum of n terms. This is the question. Okay, all right. Yes. And another thing we have to note here itself. Just look at this series. Okay, you just look at this series. Is this series a geometric progression basically? Is it a GP basically? Just carefully observe. See here, I take the first term, this is 7. 7 into 11 if I do, I will be getting the second term because 7 11s are 77. Correct? Yes. And now you try to do 77 into 11. Will you be getting this third term 777? That is 7 into 11 if I do, I am getting the second term 77. But 77 into 11 if you try to do, is it equal to 777? No, it is not equal to 777. Fine, okay. Of course, 77 into 11 will be equal to what? It will be equal to something around 800 and something. Is it or not? So 847 or something. Okay, that is how the answer comes. So you will not be getting this value to be your answer. So in this case, what we can do? This is not basically a GP at all. Fine, okay. So that GP means you must have a common ratio, right? You must have the same number to be multiplied to get the other successive terms. But this is not like that. So what we are going to do here is, we are going to do some kind of adjustment here. We are going to format something here in order to get an expression which is of GP. This is going to be the plan. Okay, fine, okay. Yes, okay. First what I am going to do is, I am going to take this as Sn. So Sn is equal to, fine, okay, Sn is equal to, so here we will just take down the terms first of all. Okay, 7 plus 77 plus 777 plus 7777 and so on. This is going like this up to n terms. Okay, let me not repeat it to each and every step. Okay, up to n terms we have. Then what I can do here is, this is equal to, what I am going to do here is, just listen to the steps carefully. Okay, now what I am going to do is, I am going to take 7 as a common factor outside. Okay, I am going to take 7 outside. So what I will have inside now, I will have 1 plus 11 plus 111 plus 111 and so on. This is what we have, right? Correct? Yes. This is going up to n terms, and up to n terms I am taking all the terms from all these terms, from each of those terms I am taking the 7 to be a common factor outside. Okay, all right? Yeah. So this is equal to, now we got all these terms to be 1 1 1 1 1 1 like this. Fine. Okay, all right? Yes. Next what I am going to do is, that should be even more important. I am going to do what is, I am going to multiply 9 with each of these terms. I am going to multiply 9 with each of these terms. So if you multiply 9, what will happen? So this will become 7 into, this 7 stays as 7 itself. Okay, 7 into, now what happens here inside is, you will have this, each of these terms multiplied by 9. So this 1 will be multiplied with 9. Okay, 1 9s are, this will become 9, plus 11 9s are will be 99, plus 111 into 9, this will be 999, then this into 9 will be 9999 and so on. See here, now you got a new pattern, but again it is almost the same, it is again the same pattern only, but this is of a different figure. That's it. Okay, fine. So now we got like this. So what we are doing here, we are just multiplying each of these terms by 9. This is what we are doing. But in order to manage, in order to tackle the calculation, what we have to do? We have to divide it by 9 also. Fine, okay? Because when you multiply by a number, you have to divide by the same number, right? That is what we are doing here. That's it, okay? Now you can see here, you can work it out. You will just get the previous step itself. I hope you can understand this, right? Okay? So what we did from the beginning, we had all 7s. I took the 7 as a common factor. We made everything to be 1. And when you multiply by 9, everything began in terms of 9s. And outside we are getting a fraction 7 by 9. This is what we are doing so far. Okay, all right. Now hereafter we are going to do some kind of adjustment. Okay, yes, I'm going to rewrite each of these terms what I have inside. How I'm going to rewrite? Just again look carefully. Okay, I'm opening a square bracket. Now see each of these terms. Okay, now first term is 9, right? This 9 I'm going to write it as 10 minus 1. Fine. Okay, all right. Plus this 99 is going to be 100 minus 1. Plus this 999 will become 1000 minus 1. Okay, 1000 minus 1 and so on. So this will become 10,000 minus 1 and so on. It goes like this. But anyways, I'm just closing it here. It is understood, right? That's why. Okay. Now see here, this way we are formatting. Why? Because each of these numbers are one less than these numbers. Which numbers? 10, 100, 1000, 10,000, 1 lakh, 10 lakh, and so on. Okay, so that is the reason I am rewriting these numbers like this. Okay, I am writing that number minus 1, that number minus 1, like this. Okay, and again what we can do here is I am again going to write these numbers. Okay, which numbers? These numbers as powers of 10. I am going to write them as powers of 10. Shall we write it? So if you try to write it, what happens? This will be nothing but 10. That 10 is nothing but 10 power 1. So 10 power 1 minus 1 plus, next this 100 can be rewritten as 10 power 2 minus 1, because this 100 minus 1, right? This 100 is what I am writing as 10 square, that is 10 power 2 minus 1, plus next I can write this one as 10 power 3 minus 1, and obviously what will be the next term? That will be 10 power 4 minus 1, and so on. This goes like this. Okay, and remember we are doing all these calculations till how many terms? Up to n terms we are doing. Okay, fine, yes. Yeah, okay, let me continue it on the right hand side. Okay, because we have some more space there. Space is not enough here. Okay, so this is equal to, now what next we can do here is, now again I am going to segregate the terms. How I am going to segregate? This is 7 by 9, right? Like write that as it is. Now I am going to segregate like how we did the two previous questions. The same way how we segregated there, the same way here also I am going to segregate the terms. Okay, so I am going to collect all these 10's powers first. Okay, when you collect 10's powers, what happens? You will start from this 10 power 1. Okay, so open a bracket, 10 power 1 plus 10 power 2 plus 10 power 3, and so on, up to how many terms? Up to n terms. Okay, up to n terms, minus, now see here, what do you have here? Here you have what? Minus 1, minus 1, minus 1, minus 1. These minus 1s are also collected. And just check and see how many minus 1s will be there. How many minus 1s will be there? There will be n minus 1s. Correct? Yes. Because since we are doing this counting, this addition for up to n terms, there will be obviously n minus 1s collected. Okay. So that means minus 1 into n. This way I am going to write. Okay, I hope you can understand this. Okay, so that means, see here, we got a series like this and we got it like this. Now if you carefully see, here I have 10 power 1 plus 10 power 2 plus 10 power 3 and so on, which is nothing but what? This is now definitely a GP. Here you see a GP, right? It is a geometric progression, is it or not? See here, 10 power 1 plus 10 power 2 plus 10 power 3. This is undoubtedly a GP only. And for this GP is what we are going to find? What? Sum of n terms. Okay, fine. Okay, all right. Yes, we are going to find the sum of n terms. I hope you remember the formula to find sum of n terms. What is the sum? Sum will be Sn is equal to a into r power n minus 1 by r minus 1. Okay, fine. Yes. But before that, we should be sure about which values? We should be sure about the values a and r. Correct? What about a and r? A is equal to what here? A is the first term of the GP. This is going to be 10 because 10 power 1 is 10. And what about r? R is going to be what? R is going to be what? Just think of 10 square by 10 power 1. Because r you usually find it as second term by first term. So 10 square 100 divided by 10 power 1, which is going to be 10, right? Okay, so that means we will have the answer to be 10 only. Again, r is also 10. Okay. Again, it is very easy for you to understand. See here, 10 into 10 will be 100, 100 into 10 will be 1000. This is easily understood, right? Ratio is 10. Okay, so a is 10 and r is 10. Now these are enough for us to find the value of that Sn. Okay, so this is equal to, continue, 7 by 9 into, now what next I have to do? Now we can use the formula. Which formula? Sn formula. Sn means, the formula to find the n terms of GP. That formula we can use. What is the formula? A into r power n minus 1 by r minus 1. We can use that formula. Is it or not? Yes. So let me use that formula here. So what happens? You will have 10 into, a into means 10 into r power n minus 1. That is 10 power n minus 1 divided by r minus 1, 10 minus 1. Okay, this is what you will have. And here also, what do we have here? Here we have minus 1 into n. That will give you minus n. So this is what we will have here. So this will be equal to, finally, what you will have here is 7 by 9 into, we can even simplify this, right? We can simplify this. So when you try to simplify, this will become what? This 10 minus 1 will become, 1 will become 9. 10 minus 1 will be 9, right? So what I will do here is, by the same hand, I will just take the LCM. Okay, the overall, the LCM will be 9. So what next I will try to do is, I will just write this term as it is, 10 into 10 power n minus 1, because this is 9 only, minus this n will be multiplied with this 9. So this becomes 9n. Fine. Okay, all right. I hope it is clear to you, right? Yes. Fine. So this is what overall you will be getting. So now what next I can do here is I can even bring this 9, because anyways this 9 is going to be a common denominator only, right? So this 9 I can bring it outside. This 9 into 9 will become 81. So I will have 9 9s are 81. So 7 by 81 into I will have 10 into 10 power n minus 1 minus 9n. So this will be our overall answer for our first subdivision. Which one? This question, 7 plus 77 plus 777 and up to n terms. The answer is going to be what? This is going to be the answer. So 7 by 81 times of 10 into 10 power n minus 1 minus 9n. This is going to be the answer for our first subdivision of this question. Coming to the second subdivision, here the question is 8 plus 88 plus 888 plus and so on up to n terms. This is going to be the second subdivision of the same question number 13. So yes, you have only a very small change. The first subdivision, there we had everywhere 777, but here you have everywhere 888. The solution is going to be almost the same process. Okay, it is going to be there. You will have the same steps, and that is the reason I kept the previous question solution. I didn't erase it. Okay, I just kept it as it is. Why? Because I can just show the thing here itself. Okay, so what will happen here is you will have everywhere 8s. Okay, so here you will have 8. Okay, I'll just use this color. Okay, so this will become 8. So this will be 88. This will be 888. This is going to be the question, right? 8888 and so on. Everywhere will be 8. And here what happens is you will take, instead of 7, here this question you will take 8 as a common factor. So what happens is, like, here also it will become 8, and these things are going to be same only, these steps. Okay, so only the thing is wherever 7 comes, it becomes 8. Okay, so it becomes 8, and here also you have 7, this will become 8. So here also, once you adjust this way, here again you will happen to get the same GP. Why? Because the content what you will have inside will never change. Okay, only this value what you have taken outside as common, that will only change. Okay, so this again 7 will be changed as 8, this becomes 8, and this will finally become 8. And of course this is going to be the answer for your question number, subdivision number 2. So what is the answer? 8 by 81 into 10 power n minus 1 minus 9, and this is going to be the answer. And if at all you want to simplify it further, what we can do is, this is going to be 8 by 81 into, you can even multiply this 10 inside. Okay, that also if you want you can do it. So once you do it, what happens is, this is 10, it's like 10 power 1, right? So 10 power 1 into 10 power n will be 10 power n plus 1 minus 10 minus 9n. That's all we can do here. Okay, yes, nothing else can be done here. So this is going to be the final answer. And for the previous question also, if you want to do this step, you can do it. Okay, there what will be the answer is, the answer will be, instead of this 8, there will be 7. That's it. Okay, no big change at all. So there we had everywhere 7s. So our answer was 7 by 81 times of this content. And here you have everywhere 8, and here the 7 will be replaced by 8. That's it. Okay, that's the only change in the solution. All the steps what you have, it's going to be the same, only with this few change. Wherever 7 comes, it can be replaced by 8. That's it. Okay, so that means this is going to be the answer. 8 by 81 into 10 power n plus 1 minus 10 minus 9 is going to be the answer for your subdivision number 2. Question number 13, subdivision number 3. Here the question is 0.5 plus 0.55 plus 0.555 and so on. So here again we have to find the sum of this series up to n terms. This is the question. So yes, this again we are going to handle a similar approach how we solved the previous two questions. Let's see how we are going to solve this question. Okay, yes, as usual what I am going to do is, I am going to take, here we have decimal numbers, we have to note that. Okay, so all these are decimal values, and again as usual we are going to take a common factor outside. Okay, so here which number we can take as a common factor? We can take 5, correct? Yes, so I will take 5 outside. So what happens is, inside we will have 0.1 plus 0.11 plus 0.111 plus and so on. This is what we will have, correct? Yes, up to n terms. Okay, that is understood in a default way. Okay, so yeah, coming back, so what next I'm going to do is, again I'm going to do the same step. I'm going to multiply and divide by 9. Okay, so first I will do 5 by 9. This is multiplied with, here inside each of these terms I'm going to multiply by 9. So what happens is, we will have 0.9 plus 0.99 plus 0.999 and so on up to n terms. Okay, this is what we will have. Okay, And again what I'm going to do is 5 by 9 into, we are going to rewrite the terms what we have inside. Okay, each of these terms I'm going to rewrite. Okay, how I'm going to rewrite is, I'm going to write this 0.9 as, just listen carefully, I'm going to write this as 1 minus 0.1. Correct? Yes, we can write like this, right? So we have 0.9, this is nothing but 1 minus 0.1. Okay, same way, plus the 0.99 I'm going to write as 1 minus 0.01. Okay, alright. Then plus, here we have 0.999. This can be rewritten as 1 minus 0.001. Okay, and so on. This goes like this. So each of these terms we are going to write it as 1 minus, 1 minus, 1 minus, and so on, like this. Okay, up to n terms. Fine. Okay, alright. Yes. Since each of these numbers are very closer to 1, we are doing like this. Okay, fine. Yes. Yeah, okay. And next, as usual, I am going to group the terms. I am going to segregate the terms. How I am going to segregate the terms is the similar way. Okay, yes. I am going to segregate the terms like, I am going to collect all these ones first. Okay, so I am going to collect these ones. So 1 plus 1 plus 1 up to n terms we will have. Okay, I am going to take this as one group. Then see here we have minus 0.1, minus 0.01, minus 0.001. These terms are here, right? So this I am going to take it as another group. Let me take that minus as common outside, and I will have 0.1 plus 0.01 plus 0.001 and so on. Like this we will be having. Okay, up to n terms. Okay, yes, fine. Now if you carefully see, this is 5 by 9 into, look carefully here what we have here. Here we have 1 plus 1 plus 1. Up to how many terms we have? We have n terms. So that means we got n ones here. So that means we can write as n times of 1 plus, sorry, this is not plus, this is minus. Now look carefully here. Here what terms do we have here? Here we have all the decimal numbers only, right? So we have 0.1, 0.01, 0.001, like this. This is the way we have. Now look carefully. I am going to write each of these terms as fractions. Okay, how we can write as a fractions? See here, it's easy, right? See here, I have 0.1. This 0.1 is nothing but 1 by 10 plus this is 0.01. This can be written as what? 1 by 100 plus this I can write as 1 by 1000 and so on up to n terms. I hope you can understand this, right? See how the way we are transforming the given expression. So we have 5 by 9 times of n into 1 because n ones are here, so n into 1 minus these decimals, each of them we are writing as a fraction. Okay, fine. Yes, yeah, fine. And yes, continue. I'm just going to continue here. Okay, on the right hand side I will continue here, is equal to, again place this 5 by 9 multiplied with, this is n times of 1, this is nothing but n minus, again open the bracket. Now look carefully here, we have what? 1 by 10. Okay, this is like 1 by 10 plus, this is 100, right? 1 by 100, right? This we can write as what? We can write as 10 square. So I can write as 1 by 10 square. This 100 I am writing as 10 square plus this is 1 by 1000. That can be written as 1 by 10 cube. See here we are writing like 10's powers. Okay, all these denominators we are writing as 10 power, 10 power, 10 power and so on. Up to how many terms? Up to n terms. Okay, fine. Yes, okay, fine. So this is equal to, now if you look carefully, okay, now if you look carefully, what we have here is, we have this bracket. Okay, this expression what you see here, this is nothing but a GP, correct? Yes. So here we don't have a GP. Okay, like how we had the first two the problems, the previous two subdivision problems, there also at the beginning we didn't have a GP, but we made some kind of transformation to obtain a GP. The same way here also we are obtaining a GP. This time we are getting a GP like what? We are getting as a fraction. Okay, now look here, we have to find this sum of n terms of this GP, for which what values we need? We need the values of A and also R, correct? Yes. Yeah, we have to collect the values of A and R. A is easily visible, the first term. Okay, the first term of this GP is 1 by 10. You just take it here. And what about R? Common ratio. Common ratio is going to be what? Just you can visualize, easily you can visualize, right? So here we have first term as 1 by 10. Second term is 1 by 10 square. Then that means with this first term, what you have to multiply with this second term? You can think that, okay, It's easy for you to say, right? 1 by 10, it's again 1 by 10. R is again equal to 1 by 10, okay? Nothing much to complicate. Or if you have doubt, you can separately find it, okay? R is equal to, how we find it usually? We will find it as term 2 divided by term 1, right? So that means we will do 1 by 10 square divided by 1 by 10. This will become 10 by 10 square. This 10 by 10 square is what is this? 1 by 10, okay? That's what I took it directly, okay? Anyways, we got the values of A and R. We have both these values. Now we can go find the value of Sn, okay? That is sum of n terms of this GP, okay? Yes, shall we go for that? So this is equal to 5 by n into n minus. Now look at here. Here we have this Sn formula we have to use. What formula is? What is the formula for Sn? Sn is equal to A into which formula we have to use here? Here we have to use r power n minus 1 or 1 minus r power n. Which one we have to use? Which one? Look carefully the value of r. R is equal to 1 by 10 here, which is less than 1. So that means we can use 1 minus r power n. Okay, we'll use that formula. Okay, so A into, that is 1 by 10 into 1 minus r power n. So 1 minus 1 by 10 power n. 1 by 10 power n, the whole power n will simply be 1 by 10 power n only. I hope we can understand this, right? Okay, because this is nothing but 1 by 10 the whole power n. I need not waste the extra step, okay? Anyways, it's going to be 1 by 10 power n, because 1 power n is simply 1 by 10 power n divided by, what will be the denominator? Denominator we have the formula as what? 1 minus r. 1 minus r will be 1 minus r, which is 1 by 10. Okay, fine. This is what we will have here. I hope you can understand this. Okay, continue this. We have 5 by 9 into n minus. Here we have 1 by 10 into 1 minus 1 by 10 power n times divided by, here you have 1 minus 1 by 10. What is 1 minus 1 by 10? This, when you simplify, you will get 10 into 1 is 10, 10 minus 1 is 9, right? So 9 by 10 you will get here, 9 by 10. So you can close the bracket. So now I can cut this 10 and 10, right? So I can cut this 10 and 10. I will have 1 by 9 here. So continue. Yes, continue. So you have 5 by 9 into, so 5 by 9 into, I think you can even take the LCM here, right? You can take an LCM, because here, now here at this portion the numerator is 1. So 1 into this expression will come. Anyways, 1 into this expression will be the same expression only. Divided by denominator is, it is only 9 now. Okay. Why? Because you cancel these two terms, right? So you have the denominator as only 9 here. Now you will take that 9 to be the grand LCM. What happens? So 9 into 10 will be 9n minus, you will have 1 minus 1 by 10 power n. This is what you will have. Close the bracket. And what next I can do is I can again bring this 9 outside. So if you take this 9 outside, this is a common denominator only. So 9 9s are, this will become 81. So 5 by 81 multiplied by, now see here we have 9n. You can take this minus inside. So 9n minus 1 plus 1 by 10 power n. Okay, fine, all right. So that means this is going to be the most simplified answer, okay, expression for your question. So this is what we have for your answer. Okay, I hope I can understand this, right? Okay, so this is your question, and this is on, after all simplification, this is what you're getting. I hope you are clear with the steps. Only thing is you should be okay with this kind of adjustments. This one you have to turn it properly, and you have to bring it as a GP sum, and then you have to properly use the formula and then get the answer. Okay, fine. Yes, all right, this is going to be the step. So answer is 5 by 81 into 9n minus 1 plus 1 by 10 power n is going to be the answer for your third subdivision of question number 13. Question number 14 with us. Here our question is, the sum of an infinite GP is 16. Okay, there is an infinite GP and whose sum of the terms is 16. This is given, and the sum of the squares of its term is going to be 153 3 by 5. Okay, they are given in terms of an it is a mixed fraction. Okay, fine. Yes, so the question seems to be a bit interesting. What is that they are given? They are given two things here. So they are given it like the sum of an infinite GP is going to be 16. Okay, so that means there is a GP whose sum of all terms is going to be 16. Okay, that is, it is an infinite GP, so sum up to infinity is what is going to be 16. Okay, yes, so we'll just start with that GP. Okay, so how will be the terms of a GP? Basically, how will be the terms? The terms will be A, then we have AR, then we have AR square, and so on, correct? Then AR cube. Like this you will be having this GP, correct? So the sum of all the terms is what is given to be what? This is equal to 16. Okay, and this is sum up to infinity. That is also we have to keep in mind. Okay, it's an infinite GP, that's why. Okay, sum up to infinity. Okay, fine. Yes, and here we have no idea about what is the first term of this GP. Okay, the A value, we don't have any idea about the value of A. And also we don't know anything about the value of R also, common ratio also we don't have any idea. So we don't know what is the first term, we don't know what is the common ratio, but one thing we can tell about this common ratio, what we can tell, this value of R will be, how will be the value, its nature will be what way, it will be definitely less than 1. Yes, this R will be definitely less than 1 only. Why? Because see here we have what, this is an infinite GP, is it or not? In question itself they have defined it. Okay, since this is an infinite GP, definitely for an infinite GP what, R will be less than 1 only. Okay, we have seen that, right? Yes. Okay, and at the same time we know the sum up to infinity formula. Yes, this is the formula, right? So sum of infinity, I mean sum up to infinity is going to be what, A by 1 minus R. Okay, let's note it. So A is the first term, so A divided by 1 minus R, this value is what is equal to this 16. Okay, fine, all right. Okay, yes, let's do something, we'll mark this as equation number 1. Fine. Okay, okay, let this be as it is, let us not disturb. Continue. Okay, and the sum of the squares of its term is going to be what, it is going to be 153 3 by 5. This is what is given. Okay, now that is what is even more important. This is what is a bit interesting in this question. Sum of the squares of its term. Okay, so already we have a GP, and now what is that they are coming to tell here is there is another series. Okay, and that series, how they are obtaining that series is they are squaring each of the terms of this original GP. Okay, fine. Yes, shall we see what will happen if you square each term, what will happen? Shall we see that? Yes. Okay, let's take the terms one by one. First I will take this A. Okay, so if you square this A, what you will have? You will have A square, then plus second term is AR. If you square it, you will be having what? A square R square. Next, okay, because AR the whole square it will become, so that means this will be A square R square, right? That's what I have written here. Next, the third term is AR square. Now what happens? AR square the whole square it will become, correct? Yes, if you square this third term, it will square, it will be getting, it will get squared the entire way. Okay, so AR square the whole square, that will become what? A square, and then R square square, that is nothing but R power 4. It goes like this. Okay, now this is what is given to be what? 153 3 by 5. This is what is given like this. Okay, they gave it in a mixed fraction. Okay, so nothing to worry about it. And yeah, coming here, now let us just see about this sequence, this series. Okay, fine. Now what do you think about this series here? This series is actually what is? Now if you clearly observe, this is again a geometric progression only, is it or not? Just concentrate here, just see here, carefully you observe it, you can visualize that, you can observe that, you can just conclude that this series what you see is again a GP only. Shall we see how it's going to work? See here, the first term is A square. Now what is the second term? Second term is A square into R square. And what is the third term? Third term is A square into R power 4. That is, they are multiplying R square to each of these terms. That way we obtain this series, is it or not? Let me repeat once again. You have A square here, A square into R square you do, that's what is the second term, A square R square. And again A square R square into R square, that will be what is this? A square R power 4. I hope now you can understand this. So that means this series what we have here is again a GP only. It is again a geometric progression. And here the first term is what? This is A square, and here the common ratio is R square. That's it. Simple. Okay. All right. Yes. Okay. Fine. So what we can do now is here again we can use the same formula, sum up to infinity. Okay, so sum up to infinity, the formula is going to be A by 1 minus R, but that is for the first term is A and common ratio is R. But for here this series, our first term is what? What is the first term? First term is A square divided by, and what is the common ratio? Common ratio is 1 minus, it's going to be R square, so 1 minus R square. Now this is what is equal to 153 3 by 5. I hope now you can understand this. Okay, fine. Yes. Now let's do something here. We will convert this 153 3 by 5 as a, it is a mixer fraction. We'll convert this as an improper fraction. Okay, we know the procedure, right? We might have done in the earlier days, young classes, you might have done that. So 153 3 by 5, this can be written as 5 into 153 first of all. So 5 into 153 will give you 75, 15, 765, right? So 765 plus 3 will be 768. So you will have 768 divided by 5. Okay, so let us take this as equation number 2. So that means we got two equations now. One is from the original GP, sum up to infinity, A by 1 minus R. This expression is 16. The other one is the new GP, whose sum up to infinity is a square by 1 minus r square is equal to 768 by 5. This is 2. Okay, fine. Yes. So we marked 2 equations, and what is that we have to find here? We have to find what? Find the common ratio and fourth term of the GP. This is what we are asked here to find here. Okay, this is the question, actual question. Okay, yes. So we got 2 informations. We are given 2 things in the question. So from each of that we built 2 equation here. And what is it we have to find here? We have to find the common ratio of this GP. That is, we have to find the value of R. Okay, I mean the original GP, and the fourth term of the GP. Okay, this is what we need to find. Okay, this GP, this is what they are referring to. Okay, the original GP's common ratio and the fourth term. This is what we are asked to find here. Yes, fine. So we have got 2 equations here, right? So that means we have to play with these 2 equations anyhow, and then we'll have to solve and then get the answer. Okay, this is what we should try to do. So what we can do here is, yeah, okay, we got 2 equations. Both of them are in terms of A as well as R, right? But we need to find the value of the common ratio. That is, we have to find the value of R only, right? So that means let's do something. We'll do something. I'll take the first equation. Okay, I'll take the first equation. First equation says A by 1 minus R is equal to 16, right? Okay, let's do something here. We will square the first equation. Okay, we'll square the first equation. Both the sides we will square it. Okay, so if you square, what happens is you will have A square by 1 minus R the whole square is equal to, right hand side you have 16 square. Okay, that will become 256. Is that okay? Yes. I'm just squaring the first equation. Okay, let me write it here. Okay, I'm just squaring. Okay, I'm writing in short. Okay, SQ, squaring the first equation. When you square the first equation, what happens? Okay, I'll even write it here like this. Okay, square. Okay, when you square the first equation, what happens? My LHS becomes A square by 1 minus R the whole square, because both numerator and denominator, they will be individually squared, is equal to, come to the right hand side I have 16. That 16 itself will be squared. That is what is this 256, because 16 square is 256, right? So this is what you have here. Okay, so we squared it. Okay, now what you can do here is, again I will do something here. Okay, I will just get the value of A square now. A square is equal to, okay, just bring this term to the right hand side. Okay, so when you bring this one to the right hand side, what happens? You will have A square is equal to 256. This will be multiplied with this one, 1 minus R the whole square. I hope you can understand this, right? So that means now we got A square is equal to 256 into 1 minus R the whole square. This is what we have. Okay, fine. Okay, now we got a relation for A square. Why we got this is, purposely why we are getting this is, now I can substitute this relation. Okay, A square equal to 256 into 1 minus R the whole square. This we obtained from the equation 1, correct? This we can use it in equation number 2 now. Fine, okay, yes. We can use this relation here, right? Why? Because we have A square equal to this relation. Now see here, I have A square appearing here in the second equation. We can use this relation in equation number 2, so that will help us to find the value of R. That's it. Okay, that's the plan. So yeah, let me continue here. I'll just erase this. Okay, I'll just erase this. Anyways, it is R is less than 1 is notated here itself. Okay, I'll erase this. So what we can have now is, yeah, we'll substitute this relation here. Once you do that, what will happen? Just carefully see it until, okay. Now in this place of this A square, I'm going to substitute A square equal to 256. 256 into 1 minus R the whole square. Remember, this is not 1 minus R square. This is 1 minus R the whole square. Okay, remember that carefully. Okay, so A square instead of A square, I just substituted this expression. Divided by, denominator what we have? Denominator we have 1 minus R square. Okay, 1 minus R square. Okay, so in a hurry, please don't cancel these 2 terms, because they both are different terms. Okay, this is 1 minus R the whole square, whereas this denominator is 1 minus R square. Okay, both are different. Okay, so this is what we are getting. When you substitute this relation here, this is what we get. Okay, this will be equal to, now come to the right hand side we have 768 by 5. This is what we have. Okay, all right, yes. Okay, fine, yes. Now we can see here our entire equation is in terms of R. Yes, finished. Now if you just go for some simplification process, you can simplify, solve, and then get the value of R. That's it. Okay, yes, this is going to be the plan. So how we can do that we have to think. Okay, first of all, we'll try to simplify the numbers. Okay, so we have 256 here, we have 768 here, so we can cut these 2 numbers, right? You can cut these 2 numbers. They're exactly 3 times. This is 256 1 times, and this is 256 3 times. You can even check it and see. Okay, this is ones and this is threes. Fine. Okay, all right. You can even go for some lesser tables like 2 table, 4 table, 8 table, whatever it is. If you wish, you can go like that also, and you can check it. This is 1 times and this is 3 times. Why? Because it's easily, you can easily visualize. 256 into 3 you get 768. That's it. Okay, so with that knowledge is what I'm just trying to do it. So we got this one like this, and next thing what we can do is I can expand this, right? We can expand this 1 minus r the whole square. So 1 minus r the whole square will be nothing but 1 minus 2r plus r square. This is simply from a minus b the whole square. Okay, a square minus 2ab plus b square. That's what I'm doing here. Divided by 1 minus r square is equal to, right hand side now we will have 3 by 5. I hope you can understand that. Why? Because here you have 1 multiplied with this expression, you will have only this expression, and here we have 3 by 5. That's what I have written here. Okay, and what next we can do now is we can do cross multiplication. Correct? We can do cross multiplication. This 5 gets multiplied with this expression, 5 into 1 minus 2r plus r square is equal to, now here we have 3 into this expression goes there, 1 minus r square. Okay, all right. Yes, I can even put a line here. Okay, because we need some more space to continue, that's why. Okay, so yeah, this is the way we will be getting, and again we'll go for simplification. Okay, we'll multiply this 5 inside. Okay, so you will have 5 ones are 5 minus 5 twos are 10 r plus again 5 ones are 5 r square. This is equal to, right hand side we'll multiply this 3 inside. You have 3 ones are 3 minus this one will become 3r square. Okay, fine, all right. I hope it is clear for you. Okay, everything is coming in a proper way. And yes, what next we can do is we'll try to bring all the terms to one side itself. Yes, we'll do that. That is, we'll try to push this right hand side terms to the left hand side. We'll do that. Yes, okay, fine. So if you do so, what happens is I'll write it in proper order. Okay, 5r square minus 10r plus 5. This is what you will have. Whatever I have here, I am writing as it is, but in a proper order. Okay, now these terms I am going to take it to the left hand side. If you take it to the left hand side, this will become, this minus 3r square will come here as plus 3r square, and this plus 3, right? This comes here as minus 3 is equal to 0. I hope you can understand now. Fine, yes. Okay, now we can add the similar quantities, similar terms. So I can add this 5r square plus 3r square. This will become 8r square. And we have minus 10r, so minus 10r, and if you see the numbers, if you have constants, you have plus 5 and minus 3, that will become plus 5 minus 3 will become plus 2, is it or not? This becomes plus 2 if I am right. Yes, plus 5 minus 3 will become plus 2. Okay, this is equal to 0. Okay, this is what finally we are getting. And even if you want, you can even simplify it further, right? Because this is 8r square minus 10r plus 2, you can factorize 2 outside, right? You can factorize 2 outside. You will get what? You will have 4r square minus 5r plus 1 is equal to 0. All right, yes, this is what you get. So this is what we are getting here, and again I can continue it here. Okay, since this is 2, I can bring it to the other side. This will still become 0 only. Okay, 0 by 2 will become 0 only, so you'll be left with only this term. Okay, 4r square minus 5r plus 1 is equal to 0. This is what you will be left with. Okay, fine. So that means we are finally getting a quadratic equation which is in terms of r. We have to solve this quadratic equation. As usual, let us go by factorization method itself. Okay, so when you go by factorization method, what happens is this 4 ones are will be 4. That means you have to factorize 4 only. So you have to factorize 4. When you multiply the two numbers, you should get 4 plus 4. Okay, because this is plus 4, right? That's why. And when you add the two numbers, you should get minus 5. Fine. Okay, in that way we have to factorize. It is not very complicated for us to think, right? When you add, it should be minus 5. When you multiply, it should be plus 4. Simple. You can take the numbers to be minus 4 and minus 1. We can take that way, right? So I'm going to factorize like this: 4r square minus 4r minus r plus 1 equal to 0. I hope you can understand this. This minus 5r I am going to split like this: minus 4r minus r. Okay, because if you factorize, you will have minus 4 and minus 1. That's why I am splitting like this. Okay, fine. So now you can factorize. If you factorize, you will be getting like from the first two terms you can get 4r as common. If you take 4r as common, you will have r minus 1 here, and here from this last two terms you can take minus 1 as common. You will have r minus 1 is equal to 0. Yes, I hope you can follow this also. So now you can do it like r minus 1 into 4r minus 1 is equal to 0. So that means r will be equal to what? You will have r is equal to either 1 or from this expression you will have r is equal to 1 by 4. I hope you can understand this step also. Why? Because when r minus 1 is 0, r equal to 1. When 4r minus 1 is equal to 0, you will have what? 4r equal to 1 and r is equal to 1 by 4. I am not giving them all the steps in detail. Okay, fine. I hope you can understand this also. Yes, so we are getting two values for r. R is either 1 or r is equal to 1 by 4. These are the values we are getting. So we got two values for r, but we'll have to see which among them is permissible. Yes, is it or not? What important condition we have here? This is an infinite GP. So in that case, how should be the value of r? R should be less than 1, in the sense, can you have r is equal to 1? Is this possible? No, this is not possible. This should be eliminated. So that means the only value of r, permissible value, is 1 by 4 only. That's it. Okay, so r equal to 1 by 4 is going to be the only value for this question. It is going to be allowed. So we'll take r equal to 1 by 4. Now with this, let's try to calculate the answer for the question. Okay, one is we are asked to find what is the common ratio. Common ratio r is 1 by 4. We got that. And next is we have to find the fourth term of the GP. Fine. Okay, fourth term. So to find the fourth term, what do we need? We need the value of a also, right? We have to find the value of a also, right? Very simple. Now we got the value of r is equal to 1 by 4. Let us substitute this in any of these original two equations, any one of these equations. We can easily get the value of r. Okay, I think better, first one is better, right? So let's substitute it here. Okay, I'll take r equal to 1 by 4, put it here. So when you take r equal to 1 by 4, if you put in equation 1 will imply what? This will imply a by, okay, so a by 1 minus r, that is 1 minus 1 by 4. This is what is equal to what? This is what is equal to 16. This is what we'll get. And what next I can do is I will just simplify this. If I try to simplify, I will be getting it as this will imply, I will just use this space itself. So I will have a by, this is actually what? 1 minus 1 by 4 is 3 by 4, right? This is equal to 16. So you will have what? You will be having a is equal to 16 into 3 by 4. That means when you cancel, you will have a is equal to 12. Okay, all right. You can simplify it in any possible ways. It is your wish. Okay, because you have a by 3 by 4. This 3 by 4 as it is, I am just going to bring there to the right hand side. So that is why I am doing this calculation. So you get a equal to 12. So successfully you got the value of a also. So now we are ready with a as well as r. Both the values are available. So finally we have to find the value of the fourth term, right? T4 will be what? T4 will be nothing but what? This is going to be a r power 3. Is it or not? Because Tn formula we know a r power n minus 1. So T4 will be a r power 3. This is equal to a is 12 into this is 1 by 4 power 3. So you get what? This is equal to 12 into 1 by, this is going to be what actually? 1 by 4 power 3 will be nothing but, I think we can directly substitute to get the answer, right? So this will be like 4 into 4 into 4. So what do you get here? I can cut these two terms. This is 3 times. 1, 4 and 12 I am cutting 3 terms. So this is 3 times. So you will have 3 divided by 4 4s are 16. So 3 by 16 is going to be the answer for the term 4. Okay, I hope we can understand this. So we are just doing the problem in a very narrow way. So we had such a situation. Okay, very huge problem we got here. So we started from somewhere. Okay, we started from these things. Okay, what is given here in this question, very important question. So we started from here, we derived all these things and we solved these two equations by putting them, and then we solved for r first. Okay, so struggle for this is the great struggle. Okay, finding the value of r is what is very much important, and this notch we should be very careful. Okay, you get two values for r, but r equal to 1 is not possible because this is an infinite GP. R equal to 1 by 4 we are taking, and we are proceeding to get the value of a, and from those two values a and r we are finding what's the fourth term. Okay, this is going to be the summarized way of this question. Okay, so finally what's the answer? Common ratio is going to be 1 by 4 and fourth term is equal to 3 by 16. These are going to be the answers for your question number 14. Next we have question number 15 with us. Here a snail starts moving towards a point 3 centimeter away at a pace of 1 centimeter per hour. Okay, so there is a snail here, and its snail is going to travel a distance. How much distance it is going to travel? 3 centimeter. Okay, it is going to start from one point and it is going to travel and reach this destination point. And what is this distance? this distance is going to be 3 centimeter, okay, and this is not up to scale, okay, fine. This can be a bigger length actually, this can be nearly 30 centimeter or whatever, but just for a visualization, okay. So the snail is going to start from this point to this point. Let us just assume this distance to be 3 centimeter, okay, fine, all right, okay. At a pace of, okay, at what speed it's going to travel? It's going to travel 1 centimeter per hour. Fine, okay. That means in 1 hour it is going to travel 1 centimeter. Okay, all right. Yes. But as it gets tired, it covers only half the distance. Okay, remember, it is going to cover only half the distance compared to the previous hour in each succeeding hour. So what do you mean by that? So that means the snail's speed is not going to be a constant speed. So what is happening? It is getting tired. So what happens is, at the first hour, what speed it is traveling, the next hour what happens? The speed will be getting half of that. And the third hour what happens? That speed, the second hour speed will be half of that, is what is third hour speed. Okay. So every hour the speed is going to be half of the previous hour. This is what they come to say. Okay. So that's what they gave here. It's going to cover half the distance compared to the previous hour in each succeeding hour. This is what is given. Okay, fine. Yes. So let us be clear. So what is the initial speed? Initial speed is going to be what? So we'll just note it. Okay. So initial speed means this is going to be equal to 1 centimeter per hour. Okay, fine. This is the first beginning speed, initial speed. Okay. Yes, fine. And later on what is going to happen? The speed is going to do what? It is going to become half of the previous hour. This is how it is going to happen for this snail. And what happens is, like, we are asked to find in how much time the snail will reach his target. So that means once it is going to start, it will take how much time to reach the destination, to the target. This is going to be the question. Okay, fine. Yes. Yeah. Okay. And of course, the very good problem in an application way they are asking this question with a real-time situation. Okay. So it's a very good question, but still the question appears to be very big in size. The way of solving it is going to be very, very easy only. Fine. Okay, all right. Yeah, okay. So this is going to be actually what they are coming to say something here. What is it they are coming to say is, the speed of the snail is going to be, it is going to be half of the previous hour. Okay. What speed is there for the snail for this hour? Next hour it will be what? Half of this hour. And the next hour it is going to be half of that hour. Okay. So in that way the snail's speed is going to it is going to be there present. Okay, fine. So in that case what we can do is, we will just try to calculate the distance traveled by the snail, or the total distance. Okay, fine. Yes, we will just try to calculate the total distance the snail is going to travel. Fine. Okay, all right. And we will calculate this for every hour. Yes, okay, fine. We will calculate it for every hour. Okay. Now just start with the first hour. Okay. First hour, what is the initial speed of the snail? It is going to be how much? It is going to be 1 centimeter. So that means we'll have it as 1. Okay. Our distance is in terms of centimeter only. Fine. Okay. So first hour it is going to be 1. Then plus what will be the distance covered by the snail in the second hour? How much it will be? The second hour it will be how much? Second hour it is going to be half of this one. Is it or not? That's what they come to say, right? It is going to cover half the distance compared to the previous hour. The previous hour is 1 centimeter, and this hour it will be how much? Half of this one, that is going to be 1/2 centimeter. Is it or not? Yes. Okay. And then plus, what happens to the third hour? Third hour, how much distance it will travel? It will be traveling half of this half, that is 1/2 into 1/2, which will be 1/4. And next fourth hour will be how much? 1/2 of this 1/4, which is going to be 1/8, and so on. This is the way the snail is going to travel every hour. Okay, fine. Yes. Now you just carefully see here. This is actually what? This is nothing but a geometric progression. Okay, we have a geometric series here, and we have to find the sum of these terms to find the total distance. And that too, what kind of sum it is? It is going to be what kind of sum? This distance will be continuing and continuing. There's no end at all. Okay, because we don't have any restriction regarding the number of hours. Okay, for the first 5 hours or the first 8 hours or the first 10 hours, how much distance it will travel. We are not asked like that way. To cover the entire distance, totally how much time it will take. Okay, so let's go for the maximum itself. Okay, so in that case, if we continue, so this stands for nothing but an infinite sum of a geometric progression. Fine. Okay, this is nothing but an infinite progression, infinite sum only. Okay, so to find the infinite sum, what values do we need? We need the values of a is going to the first term, that is 1, And what about r? R is going to be again easy. So with what number we are multiplying? We are multiplying by half, so 1 by 2. Okay, so we have the value of a and also we have the value of r. Now these two are enough for us to find the total distance. Okay, so total distance will be equal to how much? This is equal to, we have the formula for s infinity, right? Sum up to infinite terms is going to be a by 1 minus r. So that means a is 1 by 1 minus r, that is 1 minus 1 by 2. Fine, okay, alright. So this will be 1 by, what is 1 minus 1 by 2? This is going to be half. So 1 by 1 by 2 will be nothing but 2. So that means the snail, even if it is going to, even the snail is going to travel for infinite time, what can be the total distance covered by the snail? It can cover a maximum of only 2 centimeter. That is from the starting point. Okay, this is the starting point and this is the ending point. Okay, and what is the distance? This distance is 3 centimeter. That is given in the question itself, right? Okay, but even though the snail is going to travel and travel and travel for infinite time, what happens? The snail can cover a maximum distance of how much? Only 2 centimeter it can cover. So in that case, what is the question? In how much time will the snail take to reach its target? This is the question, right? So how much time it will take? Even if it is taken infinite time, the snail can only reach up to 2 centimeter and not beyond that. So that means what will be the answer? The snail cannot reach the destination. Okay, it cannot reach the target. Okay, so this can be the answer. Or in other ways, how we can tell? The snail will never reach the destination. Okay, it will never reach. Okay, never reach. So when or how much time, that way they are asking, right? So never, it will reach never. Okay, never it can reach the target. That is going to be the answer for this question. Okay, such an interesting question it is, but at the same time we just have a situation. Okay, apart from that, if we are able to connect it mathematically using the progression, it's going to be, the way of solving is going to be very, very easy. The only thing what we are observing is the GP, and if you find the infinite sum itself, the answer is 2 centimeter only. So in that case, what is the meaning? The snail can cover a maximum distance itself as 2 centimeter only and not beyond that. So that is not enough for the snail to reach the destination. So in that case, the snail can never reach the destination. This is going to be the answer for your question number 15. Now we have question number 16, and this is the last question of this exercise. We will see the question. The inventor of chessboard was a clever man. He asked the king a reward of 1 grain of wheat for the first square. Okay, we'll note it. 1 grain of wheat for the first square. Then continue. 2 grains for the second, 4 grains for the third, and so on. See how he is asking. So he is going to be having the square chessboard, and we know how many squares are there in a chessboard. We know that, right? A chessboard, it's going to be a grid of 8 by 8 grid, correct? Yes. So you have 8 by 8 grid. That is what is the structure of a chessboard. So that means totally how many squares you will have there? 8 8s are 64 squares you will be having. Fine, okay. And for each square, see the amount of grains he is going to ask. Okay, how is he asking? So for the first square, he is asking how much? He is asking 1 grain. Then for second, he is asking 2 grains. For third square, he is asking 4 grains, and so on. Correct? Okay, this is how they are giving, and so on, doubling the amount of the grain for each of the subsequent squares. Okay, so that is for each square, the number of grains is going to get double. Okay, so if this pattern continues, then fourth square, how much grains will be there? Fourth one will be, it is having how much? Again double of 4, that will be 8. Okay, so that is the way it will be getting doubled each time. Okay, so this is the way the pattern is going on. Then in that case, how many grains would have to be given in total? Okay, that means totally for the entire for all the squares in the chessboard, how much total number of grains to be given? This is going to be the question. Okay, all right. Yes, so we'll have to solve this question, and yes, we'll directly get into the total number of grains. Okay, so total number of grains will be nothing but, it will be nothing but what? It will be 1. Okay, then plus 2 plus third one, it will be 4 plus fourth will be 8, and so on. Okay, this is the way it will be going. 1 plus 2 plus 4 plus 8, and it will be going and going and going until how many squares you have to do this? Up to 64 squares you have to do. That means there will be 64 terms in total. I hope you can understand this, right? Yes, clear? Is it clear? So 1 plus 2 plus 3, 4 plus 8, and so on, up to 64 terms we have to take this summation, this addition, that will give you the total number of grains. Fine. Okay. All right. So this is what is going to be this calculation, and let us see how we can solve this question. Okay. Yes. Fine. And first of all, by viewing itself, we can easily observe that this is going to be a geometric progression. Is it or not? Why? Because the terms are getting multiplied by 2. Is it or not? 1 into 2 is 2, 2 into 2 is 4, 4 into 2 is 8, and so on. So that means this is a geometric progression. For this GP, we have to find the value of Sn. That's all. Okay, fine. Yes. Okay. So how to find the value of Sn? For which we need the values of A and R. We can easily obtain these two values, right? A is 1, first term. And what about R? R is what? R is going to be, with what number we are multiplying here? We are multiplying by 2, right? So R is equal to 2. That's it, very simple. So now we have to find the total. How can you find the total? Total, we have to use Sn formula. What about Sn here? Sn formula, you remember it, right? A into R power n minus 1 by R minus 1. This is the formula we can use here. Why? Because here R is 2 greater than 1. So we can use this formula. Let's just substitute those values. Okay, fine. So if you substitute, you will have A into, that is 1 into R power n. So 2 power. What about n here? N is going to be what? How many terms are here? There are 64 terms. So n is equal to 64. Okay. So 2 power 64 minus 1 divided by R minus 1. So 2 minus 1. This is what we will have. So this, when you simplify, you will be getting what? 2 power 64 minus 1 divided by, this is going to be 1. So our answer will be 2 power 64 minus 1, and that is going to be the total number of grains in the chessboard. Yes friends, I hope the concepts and the problems, the way how we solved everything is very clear to you from this exercise. And if at all any doubts you have, you are most welcome to comment it in the comment box. And also when I see it, I'll say to rectify your doubts. Okay, alright. Again, we'll catch up in the next session with some other exercise solving problems. See you soon there. Thank you so much.